This project can help you crack multiple offers in 2025 because you will master Spark structured streaming, PySpark transformations, dynamic data ingestion, integrating Python control flow and conditionals with PySpark, building modular code with Python classes and utilities, handle incremental load and upserts, and you will build your gold layer of medallion architecture using DBT, which will cover DBT dynamic sources, Jinja functions, incremental DBT models, DBT CLI, DBT properties and configs, ephemeral materialization, slowly changing dimensions, DBT snapshots, and much more. Do you know what? PySpark and DBT are the hottest topic right now in the world of data engineering, and by the end of this video, you will master PySpark and DBT. Trust me, and this will eventually help you to crack your dream role this year. If you are excited about this end-to-end complete data engineering project, so just let me know in the comment section and let's get started with this amazing project. So what's up my fam? Happy Sunday first of all. And do you know what? This Sunday is very special because of another project without wasting any time. Because do you know what? The project video is already recorded. So I know the knowledge that you're gonna get in this particular project video is next level. So let me just give you a quick overview of this project that we want to build today. First of all, this project is pure open source. That means we will be just using open source frameworks, PySpark and DBT and Python. So this is something that can actually help you to ace in the interviews, because you can sit in any interview, Azure, GCP, AWS, whatever, because everywhere we use PySpark, DBT and Python. Pure skills. And you know what? I don't know, like if you can just interpret the depth from this particular architecture, but if I just tell you, because the video is already recorded, if I just tell you each layer is full of, you can say, real world scenarios. If I talk about bronze layer, okay, let's go with this particular architecture. So first of all, we gonna work with PySpark streaming as our source. Okay. So we have our source files, we have our source, and we have stored our data in the data lake. We gonna directly start with something called as Spark structured streaming to incrementally load our data. And do you know what? We gonna create dynamic notebooks to incrementally load data, pure Python and PySpark. We will be using loops, arrays, and some classes as well. So it will be very fun. So this will land our data into the bronze layer, and yes, the platform will be Databricks that will be using to run our Spark code. The platform will be Databricks, but the code will be pure PySpark, so you can just run that code anywhere. Okay, then once that particular, you can say, code or basically layer, bronze layer is built as per the medallion architecture, this data will go to silver layer. And let me just add that particular arrow which is missing. It's fine. Real time architecture. So so let's say, by the way, it is matching. So this bronze layer data will go to the silver layer, and you know what? In the silver layer, we gonna create Python classes which will make our code modular, so that we do not need to build the class, basically any kind of transformations, because we will be using classes, Python classes, pure Python classes with PySpark code. And these kinds of scenarios are the hottest topic right now in the interviews, because this test your knowledge, both conceptual plus implementation, both. Make sense? And we're gonna just work with Python custom modules or basically utilities. Then DBT, the core of this video, basically heart of this video, basically every layer is the heart. I'm just telling you, like bronze, silver, gold, all these three layers are insane in this particular video, because I literally didn't realize like what will be built in this video. But when this video is complete, I was like, what, man, this is amazing. So now obviously we're gonna build our star schema in the gold layer and using DBT. It's not like very overview or let's say high level DBT integration with PySpark. No, very much in depth. You wanna learn about models, about models, sources, and then Jinja functions. Yes, you're gonna just use Jinja templates as well. Then we're gonna use loops, if conditions. Then we also gonna use snapshots. We're gonna use, you can say, YAML files, personalized configurations. Everything will be in the DBT, pure DBT. And we'll be building our dimension and fact tables using this DBT. Plus, we also gonna learn how we can just work with incremental data and upserts in DBT, which is next level thing. everything is discussed in this complete end-to-end data engineering project video. I know you are really excited. I know I'm double excited because I know the quality of content that is already created. Just one request, just drop a lovely comment on this video because this will help me a lot so that I can just continue creating more and more these types of videos. Plus, I have a great news to celebrate with you all, and let me just tell you what's that. So now let's actually congratulate these people who have recently cracked the interviews in the MNCs in maybe whatever company they wanted to. So many congratulations, and I also want to see your name here and how you can just achieve this thing by just simply following the things that we are discussing in the videos, discussing in the projects, and just be focused. That's it. And I am literally waiting for your comment to be here because I would love to feature it. I know that I will not be able to just feature all the comments, but yeah, if I am just featuring some of the comments, you can just literally feel that, okay, we are celebrating wins of our data fam, and I would love to celebrate your win as well. So many congratulations. So now let's talk about our data. Okay, and we have selected an amazing data set for this particular project, and just scroll down, and this is the repo, by the way, Ansh Lamba YouTube, and just scroll down and just click on PySpark DBT project because this is a PySpark DBT project. So obviously the folder name is same, and these are all the CSV files that you can also download it, okay, in your local system because you'll be just using these CSV files. And this is basically a kind of Uber data set, okay, and we have just picked this particular data set. Why? Because this will give you a sense of dimensional data model, which is basically dimensions and fact tables. Make sense? And this is a kind of data modeling technique that data engineers work with. And dimensional data modeling is one of the most popular and most in-demand data modeling technique that you should know. Okay, makes sense? Very good. Fact tables, dimension tables, incremental data, slowly changing dimensions, everything will be covered in this particular project video. And just be with me, pure PySpark and DBT, pure. Okay, very good. So now this is the data that you can download. Okay, and now let's get started with our second thing that you should know, which is nothing but your environment. So which environment we should use for PySpark? Obviously, we can just develop all the things locally using our own system, but I know not everyone will be having the laptop with good RAM, with good memory, with good processing units, right? So what we're gonna use Databricks free edition, which is totally free. We do not need to even add a credit card or debit card, nothing, which is totally free. And this particular, you can say, Databricks free edition will help you to just run your PySpark code. That's it. We just want to use a platform to run our PySpark code. Make sense? And it is the best platform to run PySpark code and obviously all the big data things. Make sense? Very good. So how you can also create your free Databricks edition if you haven't created, simply go on Explorer and simply type Databricks free edition and hit enter and simply select try Databricks for free. Okay, and I have already created this one, so let me just open an incognito mode, maybe here. Okay, Databricks free edition. Makes sense. So if you click here, try Databricks for free, and then you will see this one, get free edition instead. Do not click here because this is just, you can say, express edition, which is just available for 14 days, but you want something which is available for a longer period, right? So simply click on get free edition instead. When you click here, then you can just click on sign up. Make sense? Sign up for free edition. Simply create your account here and that's it. Once you create your account here, you will be able to land on this particular page and click on this particular thing. And this is your Databricks homepage, which is loading. Perfect. So this is your Databricks homepage. Simple, sorted. Very good. So I know that you would know a little bit about Databricks. Okay. By the way, we are simply focusing on PySpark, so that's fine. But if you want to learn and explore in the field of Databricks, you already know from where to learn this, right? Okay, makes sense, because see, Databricks is in demand and it is actually growing a lot, this platform instead. Make sense? So just go with the flow, just get the right knowledge at the right time. And this is the right time to gain knowledge in Databricks. Make sense? Make sense? Common sense? Okay, so this is our Databricks environment. So first of all, we need to create a catalog, because obviously I would expect that you should have some knowledge in Databricks, but it's fine even if you do not have. Basically, just follow the steps because we are focusing on PySpark, but still you would need to handle your metadata, right? So for metadata, we create something called as catalog in Databricks. Make sense? Do not make it complicated. It is very simple. Simply click on catalog and you will see all the catalogs available. Make sense? These are some of the catalogs that I created for my previous videos. You can simply ignore, and that is fine. We will simply create a new catalog. Click on plus add and click on create a catalog. And let's create a catalog called PySpark DBT. This is our catalog name. Simple. And then simply say create and configure catalog, and then scroll down, next, save. And our catalog is created, and this is the catalog name, PySpark DBT. Make sense? What is catalog? Catalog is basically the data management feature, which is equivalent to, you can say, database, kind of. If you are coming from SQL background, catalog is equivalent to database. Okay. And then we have schema here. Okay, and we have default schema, we have information schema. These are by default 2 schemas, and we will also create our own schemas for different layers. As you know that we are going to follow medallion architecture. So in the medallion architecture, we create 3 schemas: bronze, silver, and gold. Make sense? But even before creating those medallion architecture, we will create one more schema, which will be source schema. Because our source can be anything, right? It can be SQL database, it can be APIs, it can be literally anything. In our case, it will be CSV files which are stored in the data lake. Now, the good thing is this Databricks free edition is automatically attached to the data lake. And what is the provider of that data lake? AWS. It is already attached to it. So we can leverage something called as volumes. Okay. And you do not need to worry about what is volumes, because this is just our source. And being a data engineer, you do not need to actually worry about how to create the source. You should be worrying about how to use the source. So in this particular section, we will be creating the volumes, but it is fine if you know about volumes. If you do not, it's also fine, because you are simply creating the source, right? So let's simply create a schema. Click on these 3 dots, or basically click on create schema, and I will name it as, let's say, source, and click on create. So this is my schema called source, and within this source, I will create a volume. Okay. Make sense? A volume. Okay. So click on the schema, click on create, and then click on volume. Make sense? And volume name will be, let's say, source data. Okay. And this will be managed volume, and then click on create. Make sense? So this is my volume called source data. Make sense? Make sense? Okay. Very good. So this is our source data volume, where we'll be uploading all the CSV files. Make sense? All the CSV files. Okay. So there are basically 2 ways. Either you can upload all the CSV files here within this volume, or you can create dedicated folders for each file. Choice is yours. Make sense? Make sense? Make sense? Make sense? Choice is yours. So it's up to you how you want to just do that. Okay. So in order to do that, I can simply click on this particular volume, and then you can simply say create directory. Okay, create directory. Create directory means you want to create a folder within your volume. And what is the advantage of it? Advantage is very, very simple. Advantage is you can simply store, if you have multiple files, within the dedicated folders. Makes sense? Okay. So it is a good practice to create a folder for each particular file. Okay. So let's say I want to create a directory for trips, because I have trips file. Okay, I will simply say create trips. So this is my directory now. See, trips. And even if you refresh this area, you will see that folder created here. Here. If you click here, this is the trips folder. Make sense? So this is my first directory. And within this directory, I can upload the data, any data. See, upload to this volume. So if I click here, upload to this volume, and if I click on browse, make sure that your data will go to trips. make sure that trips is here. Otherwise it will load all the data in the root directory, basically root location that we do not want, right? So let me just click on browse and let me just add that trips file. Okay, so trips.csv is added. Okay, and we have the option called overwrite files with the same file name. If you have any file with the same file name, it will overwrite it, but we do not have the same file name, so it's fine. Click on upload. So this file is uploaded called trips.csv. Make sense? And whatever we have trips, then we have vehicles. Okay, then we have vehicles. So I will simply click here. Okay, I'll click on source data and you can see one folder here, trips. Make sense? Then I will click on create directory and let's create a directory for vehicles. Okay, makes sense. Now let's upload to this volume. Same step. Let's say vehicles. Perfect. Upload. Okay, sorted. Let's create another folder, create directory, and this directory name will be customers. Makes sense. Very good. Customers are here. Okay. Then let's upload to this volume. Customers. Perfect. Okay. Now we have drivers. Let's create drivers. And then within this drivers, I can upload the file. Okay. Then we have locations. Let's create directory of locations. And then we have locations file. Then we have payments. Okay. Then we have payments. Perfect. Then let's upload to this particular volume. And let's say payments. Okay, so this is also done. So now all the folders for our volume are done. See, all the folders are here. Why this is helpful? As I just mentioned, that if you have more and more files, and let me just tell you, we will add more and more files in these folders because we also want to see how we can incrementally process and load the data. So all the things will be covered in this particular video. Just sit back and relax and just code. Okay. So this is our data source that we have created within just 5 minutes. And if you understood this part, it is fine. If not, it is still fine because it is like very simple. It's not a big deal at all. Okay. So perfect. So this is basically the volume that we have created. Okay. If you click on this folder, customers, and if you click on the CSV file, you will see that this is the CSV file. Okay. And if you just click on copy path, and if you just paste it here, you will see that this is a path to the volumes. Okay. This is the path to the volumes that you use in Spark code as well. And I will just show you, don't need to worry at all. Make sense? Make sense? Okay. And if you just go to files, these are basically all the files. These are the details. And this is the managed meta store that is created for us. Okay. Perfect. Then permissions are here. Okay. Perfect. So now finally we can just create our first particular folder. So simply click on home and click on create and then click here to create a folder, and folder name will be like, let's say PySpark DBT project. So this is my folder name, and within this folder we will be creating our notebooks. Why notebooks? Because notebooks are the building blocks for your Spark code. Whenever you want to write code, you always go for notebooks. Yes, you can even create Python files, but notebooks are better to interpret. Notebooks are better when you want to run your code in chunks, and this is a recommended approach as well. Make sense? Okay, so let's create our first notebook, and I will call it as notebook, and let's close this, and this is my UI. So basically, if you would not be seeing the same exact UI, you can go to your name, click on settings, then click on developer, then go to the bottom and just click here, tabs for notebooks and files. Okay, so this is basically the new feature that we have within the Databricks UI, so that we can just open our notebook in the form of tabs. See, this is the one notebook. If I want to open second, then we can just create tabs, and this feature was not there before. So perfect. So let's first of all rename our notebook, and I will name it as, let's say, bronze ingestion. Bronze ingestion, because we want to ingest our data, okay, in the bronze layer first of all. Make sense? Make sense. And do you know what? We gonna work with dynamic notebooks. Okay, dynamic notebooks. We do not want to just, let's say, run our code just for like one file or basically one source. We want to dynamically do it. Okay, and how we can just do that, I will just show you. Everything will be done using Spark code, pure Spark code. Do not need to worry at all. We'll be just creating classes, loops, conditionals, everything. Okay, so first of all, let me just show you how our data looks like. So if I go to catalog, the third icon, so this is my catalog. It's called PySpark DBT. Perfect. And this is my schema source. Okay, perfect. So this is my data, source data. So if I want to first of all look at the data that we have, like so many folders, how we can just first of all look at this data? It is very simple. Just attach your notebook with a cluster. What is cluster in Apache Spark? Apache Spark basically runs on compute, right? Compute is the backbone for Apache Spark. It runs with distributed computing engines. So for that you need clusters, right? So this is basically an amazing feature called serverless compute, which will automatically, you can say, add more and more nodes if required and reduce the nodes if you are not working with more and more data. So it is like auto scaling. You do not need to worry about anything. Auto scaling, serverless. Plus, serverless means you are not managing the virtual machines. Databricks is managing the virtual machines on its end. So everything is on the Databricks side. But if you do not want to create serverless compute, if you create all-purpose compute, then in that particular scenario, you will be managing all the VMs that you do not want, right? So just go with serverless and that's fine. So now let's see how you can just look at the data. First of all, okay, very simple. Simply say df equals spark. Let me just increase the size. Spark dot read dot format. Okay. And what is the format of our files? It is CSV. Perfect. Then we will say dot option and header equals to true. And in PySpark, you should know that we just create header equals true. Okay, for CSV especially, because CSV do not carry any kind of header. Basically, they carry header, but they do not carry any kind of schema. So that is why we say, hey, just make the header as our schema. Simple. Okay, then we need to say dot option. What else? We can say infer schema equals true. If we do not specify infer schema true, it will treat all the columns as string columns, because by default CSV files will store all the information in the strings, right? So that is why we need to say infer schema. Make sense? Good. Then I will simply say dot load. Now in the load, you will know that we always pass the location of our file. Now what is the location of our file? Because we can either work with databases, we can either work with, let's say, data lakes. And obviously in the modern world, we work more with the data lakes. So what is the location of the data lake? You actually do not need any kind of location of the data lake. You just need the location of volumes, because volumes is your source. Volumes are built on top of the data lakes. Make sense? So how you can just get the location of volume? Simply click on source data, and whatever folder you want to read, let's say you want to read customers data. So you can click on these arrows and the location will be inserted. But there's a specific, you can say, way to write the location, and it is saying, by the way, who will add the dot? Okay, perfect. Spark dot read dot format. Perfect. So load. So we simply first of all write volumes. Okay. Then we write the catalog name. Catalog name is DBT project. Then we write the schema name, which is source. Okay. Then we write the you can say volume name. Volume name is source data. Then we write the location. What is the location? It is simply a folder called customers. That's it. That's it. Simply run this. Okay, simply run this. And this is the location. This is the format. How you can just specify the location in the modern world where we use volumes which are built on top of your data lake. Make sense? Okay, good. And if you do not remember this particular thing, use the advantage of UI. Simply click here on the two arrows and it's fine. See, it's exactly the same. Make sense? Let me just rerun it. And in order to see this data, simply use display command, display df, and hit enter. Basically shift plus enter. If you want to run this cell, you can either click here or you can hit shift plus enter together. So this is my data. See, all the things are here, and do not worry, these are pseudo phone numbers. So do not try to, hey, let me just call them. So these are basically the data for customers. Make sense? And this is such an amazing data set that we also have last updated timestamp. And this is basically the Uber data set that we have. Pseudo one, but yeah. And this is that data frame, basically that data which is used in the real world. That is why you are seeing all the information like last updated timestamp, sign up date, because these are the things that exist in the real world. And I can say that I try to create the projects in such a way that you can actually highlight those in your resume smartly. And you can actually say that, hey, I have built this project. And by seeing those projects, see, obviously it is it totally depends upon how the person is displaying that project. But if you are able to confidently and smartly just showcase this kind of project, the other person will feel that actually this person has like worked on real data and real project, and let's actually give, you can say, some more, you can say, consideration on your profile or anything. Because there is a myth that you can only showcase the projects which are built in the industry. No, if you have built your hobby projects, or basically you can say any university project, but if those projects are of that level, those will be considered as well. Those will be considered as well, because it is not just about creating a very simple, very entry level project. No, we are building actually a production level, the real world project. When I use the word real world, I mean it. It's not like just adding real world and that's it, and building simple project. No, there will be challenges. There will be exact environment that you will feel in the real world. And if you do not trust me, just talk to anyone who is already a data engineer. Okay. The real one, not the one who would like to, you can say, criticize me. Just talk to some real developers and just ask, hey, I'm building this project. Is it anywhere relevant to the industry or basically in your organization that you work with? The person will say, definitely yes. Definitely yes. Make sense? Good. So this is my data. Okay. And this is my data frame. And if you have some fundamental knowledge about medallion architecture, in the medallion architecture, in the bronze layer, we try to write the data in the as it is form. As it is form. We do not need to apply any kind of transformation. Why? Because we also need to have a kind of source of truth for our pipelines. And bronze data is the exact replica of the source. Make sense? That is why we never apply any kind of transformation. Never. We simply append the data as is. Make sense? And obviously we want to just load the data incrementally, and I will just show you how you can just load the data incrementally. Because let's say today in the customers folder, we just have one file, right? Customers.csv. Tomorrow there will be a new file, because obviously there can be new customers, then another, then another, then another. So there can be like multiple files, right? So we do not want to process all the data, because in the world of big data, we do not process all the data every time, because obviously it will be linked to the cost, right? So in the real world, we load the data incrementally. So how you can load the data incrementally? We will be using something called as PySpark streaming. Yes. Do not feel like, hey, we're gonna use Spark streaming or PySpark streaming. Like it will be very difficult. No, it will be very easy. It will be very easy. And you can literally highlight a project in which you have also used real-time data processing. And it's a big deal. It's a big deal. Trust me. Okay, so now let's see how you can actually process the data. Basically, not process, like basically ingest the data incrementally. Okay, very good. So now we are all set to incrementally ingest the data. And for that, let's first of all create our schema. Okay, so let's go to catalog and let's create a new schema within our catalog, and let's name it as bronze. Make sense? Bronze schema. Perfect. Click on create. And within this bronze schema, we do not need to actually worry about the data lake, because obviously we will be creating the tables, which are delta tables for our bronze table, but we need to store the metadata for those tables. So that is why we will be creating a data lake volume, so that we can store the, you can say, metadata, not basically metadata, basically the checkpoint, like to identify which file we need to process and which file is already processed. This is basically the fundamental of Spark streaming. And if you do not know, no need to worry, I will just show you step by step. So for this, let's create a volume, and volume name will be, let's say, checkpoint. Okay, checkpoint makes sense. Click on create. So this is our checkpoint volume. Okay, so let's go back to our bronze ingestion notebook. Okay, so now what are we gonna do? Let me just change the theme first of all. Developer dark mode, perfect. Bronze ingestion. So okay, so this is our notebook. Okay, so what are we gonna do? So this is our display df that we have displayed the data frame, right? And this is our static data frame that we just wanted to see the data frame. But what is the what is the other purpose of this particular, you can say, batch reading? Because obviously we are working with Spark structured streaming. So what is the advantage of it? So see, whenever we want to work with Spark structured streaming, we should always define the schema for our data frame, always, so that it can automatically detect, hey, this column should be of this data type, hey, this column should be of this data type, and so on. Okay, so there are now basically two ways to define the schema. One is you can manually add the schema one by one. The smarter way is when you just write, like, let's say, when you just write your code for reading the data frame, you can run one command called df.schema. And if you hit and if you just simply run this, you will see this is the complete schema. You can see that customer ID is of integer type, first name is of string type. So basically this is the schema that we have got from the batch reading, and Spark has automatically inferred the schema for this. If you are satisfied with the schema, you can actually store it in a data frame called, let's say, schema underscore, let's say, trips, or basically customers. Okay, and then you can define it, schema customers. Make sense? And if you are not happy with the schema, let's say you want to change one data type, let's say customer ID, you want to keep it as string type, let's say. So you can simply copy and paste and change it manually. So this saves a lot of time, where you do not need to define each and every column manually. You can simply get the schema and change the desired columns. That's it. You do not need to worry about all the schemas at all. Make sense? I hope it makes sense. So we will be also doing the same thing. So this is our schema customers, and this is for like just the customers one. Okay. So now let's say I want to now start my streaming data processing, right? So how we can just do that? Let me just add a text, and I will simply say, let's say h3 and bold, and I will make it as Spark streaming. Okay, Spark streaming. So in this particular Spark streaming, we can simply define our data frame, and we can read our data frame using stream method instead of batch method. So the code is very much similar. So it says spark dot read stream instead of read, and then format, and I will simply say CSV. Okay, and then I will say dot option header true. Then I will say schema instead of infer schema. Now we need to say schema. So schema will be my schema customers, right? And this is my data frame, and I do not want to display it. Okay, so this is my data frame that we have read using streaming method. Perfect. Let me just run this. What will happen? Nothing, because of lazy evaluation we have just defined what we need to do. Now we want to write this data frame into the bronze layer, and we want to create a table on top of it, right? So I can simply say df dot write stream dot format, and the best format is delta. Okay, then we can say output mode. So now what should be the output mode? So output mode should be append. Should be what? Append. Why append? Because we want more files to be appended every time we will be running this particular stream. Make sense? So I'll simply say append, and then I will say dot option, and then I need to define the checkpoint location. Now what is this checkpoint location? So basically checkpoint location helps Spark to know which files are processed. So let me just tell you. So let's say this is your Spark, right? This is your Spark, and not Spark, basically this is your, let's say, source. Okay, and here is your Spark. Okay, makes sense. Okay, and this is your destination. So this Spark engine will read the data from the source and write the data to the destination. Makes sense? Let's say this is one file and one file is here. Now next day you have another file. Let's say this is the new file. This is the new file. Now it needs to just process this file instead of both the files, right? So how Spark will know that it has already processed this file? So that is why it creates something called as checkpoint location. As the name suggests, it is a checkpoint. So it will take care of that particular Spark streaming query that, hey, I have already processed this green file. Already processed this file. So the file name, the metadata of the file, everything will be stored here. So before processing the next write stream, it will read the checkpoint and will say, hey, this thing is already processed. So I just need to process this particular thing and just push it into the destination. This is the advantage of Spark streaming checkpoint location. And we need to manage this particular location. That's why I created that particular volume to store that information, right? Perfect. So I will simply say checkpoint location, and what will be the location? As you know, if you go here and this is our schema bronze and this is my location. Okay. So far we do not have any kind of folder in this, but we will create one folder like this. Let's say this one, and within that I want to create a folder called customers. So what will be the advantage of it? The advantage is very simple. So within the checkpoint volume, we want to store all the checkpoints for customers, trips, locations, everything. Make sense? Very good. Now I will say dot trigger. Now this is very important. So whenever you want to just work with, you can say, streaming, basically real-time data, we want our pipelines to run in an interval, right? 5 seconds, 10 seconds, 15 seconds, or maybe 1 second, 2 seconds, 3 seconds, so forth. So it's up to you how you want to just process your data. Makes sense? It can be 1 second, 2 seconds, 3 seconds. So you can simply say processing time equals, let's say, 10 seconds. Okay. You can write like this, but obviously we do not want to process our data or basically run our data notebooks in every 10 seconds. So I will simply say once equals true. What is once equals true? So what it will do, if it has processed your files, it will stop, immediately stop. Then when you will be just triggering it next time, then it will read only the incremental files, then stop. Then next time incremental files, then stop. So this way we can save our compute. And obviously if we are using free edition, we cannot use the compute which will be just charging a lot to Databricks, because you are learning and you do not want to create a long bill for them. So that is why we always use once equals to true in the, you can say, environment where you do not want to spend a lot of compute. Make sense? Okay. But yeah, in the real world, you can simply use processing time 1 second, 2 seconds, 3 seconds, 10 seconds. But here we will simply using once equals to true. Once it is loaded, then stop. Simple. Perfect. Then at the last, we need to simply say dot to table, and we want to create a table for this. And we want to create a table in this catalog, DBT, not DBT, I think PySpark DBT, then bronze, then customers. Make sense? So this is our code that we want to write for the Spark structured streaming for incrementally loading the data. But how we can just make it dynamic? That is the question. Because if I run this code, it will simply load the data for customers. Simple. Then if I want to do it for locations, then I will be just copy and pasting it in the next cell, then next. You will be saying, yeah, that's what we do in the real world, right? Yes, but I want you to become an efficient data engineer, a pro data engineer. How you can just become the one? By obviously doing the special things, not like the things which are not being done by everyone else, right? So the best way to process this data that will make your resume highlighted or basically your project highlighted. Dynamic ingestion. What do I mean by dynamic ingestion? So basically, first of all, I want to just show you what is the static thing here. The static thing is obviously this location, obviously this checkpoint location, obviously this table creation mode, and then this schema. Let's talk about schema at the end, because that is the, you can say, in which you want to just perform a little bit of pre-work, but that's fine. But how we can just make everything else dynamic? It's very simple. So I will simply create a list of variables, because obviously I can just show you a lot of ways, but I just want to show you the PySpark way, so that you will not be stuck with any kind of, you can say, tool that you're using. You can simply run this PySpark code anywhere else. Okay. So I will create a code cell and I will simply say, let's say entities. Let's say I have these entities and I can pass the list. I have customers. I have, I think, trips, right? Then I have locations. Then I have payments. Payments. Then vehicles and customers. No, customers is done. Vehicles. Okay. Because I always prefer dynamic things, because dynamic data solutions are the hottest topic right now. Every organization or basically your hiring manager will feel happy if you have built dynamic solution, because static code is not very reliable in today's world, right? So vehicles is done, and then drivers. Okay. So this is my list of entities that I want to process. Make sense? Okay, makes sense. So this is my list. Perfect. So what I will do, I will run a loop. Okay. I will run a loop. Oops. So I will simply say for entity in entities. Okay. And then I will remove all these things with a variable. I will simply say f. This is basically f string in Python, and I will simply say entity. Okay. And here as well, in the checkpoint, I will say entity, so that it will create a dynamic folder for all the entities. And then table name as well. I want to create a new table for each entity. So this is done. This is very simple. Make sense? Very good. Now the only thing left is this particular schema customers. So how we can just work with this thing. Okay. So for this particular thing, you will create basically array, basically not array, schema array for each entity. So this way you have schema customers like this. Makes sense? Let's say df.schema. They're like basically so many ways, but I want to just show you so that you can just perform everything in a dynamic way. Everything in a dynamic way. Make sense? So what I will do, I will simply copy this code for the batch read. Okay. And I will even paste it here. And I will just show you the manual way as well, because choice is yours. I want to make everything dynamic, but you can just follow a hybrid approach, manual plus automatic. So here I will simply say customers. Here it will become entity. Okay, entity. And then we can say entity schema. Entity schema equals df.schema. Okay. So it will become schema entity. I hope you are absorbing the knowledge what I'm trying to do. Df batch. Okay. And then this will become df batch. Perfect. So what we are trying to do, we are simply running a loop. Okay. So first it will go and process this batch data and will simply read it. Okay. And you know, whenever we just read the data, we actually do not consume a lot of computation. Okay. Even if we have hit the trigger, because it will simply read a few files. That's it. Then it will simply grab the schema for it. Okay. And then it will start the stream processing and it will pass that schema here. And we can just change the variable name here, which will become schema entity. Make sense? And this way you can actually do this processing easily. This is your full-fledged dynamic solution for ingestion into the bronze layer. You didn't define any schema. You didn't write any schema, you didn't define any data types, you didn't define any location, you didn't define any table, and you didn't copy the code. Nothing. Just pure dynamic solution, and that's it. Makes sense? That's how you build the real world solutions. Okay. What was the second way if I do not want to include this code in my processing? So for that, what you will do, you will go here and you will keep on adding this particular schema in basically a list of dictionaries. Basically this is schema customers, then schema this, then schema that, and blah 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 blah, so many names. Okay, so that particular array will look like this. Let's say array. Okay, so this will be dictionary. Okay, and this will be, let's say, name, and name will be, let's say, customers. Okay, and here will be schema. Okay, and schema will be like this. Let's copy this one. Schema will be this one. Okay, so this way, this is your first entity, then second, then third, then fourth. So you will be keep on doing this thing. So this will become your array. Okay, this will become your array. And instead of running a loop on just a list, you will run a loop on the array. And here you can simply use the keys of that list. Make sense? So let me just show you. I actually deleted it. So let me just create another one, array. Okay. So let's say name. Okay, let's say name is customers, and then schema. Schema is this one. So if you want to just run a loop, you can just do like this. So for now we have just one entity. Let me just copy and paste it, and let me just show you, just for your understanding, because I want you to know everything. Okay, so this is my array. So you will run something like this for I in this array. Okay, and if you just want to use any kind of, let's say, array, okay, so you can simply say print I dot array, not array, basically schema. Make sense? Because this is a dictionary, right? Dictionary of two keys, name and schema. See, this is a dictionary of two key value pairs, name and schema. These are basically your two key value pairs, right? So these two key value pairs, you can simply pick the schema. Makes sense? Because this is a dictionary. So just print I dot schema, and let's see. Okay, makes sense, because this is a dictionary, not a tuple. So you will simply write like this, I of schema, because each element of the loop is a dictionary, right? So see, that's how you can just use a schema. So choice is yours, both are fine, but I just wanted to show you more dynamic way. And now you know. Okay, perfect. So I can also remove these two cells. These are not required anymore. Perfect. So this is my code and that we have written. So I can now run this code, and let's see if we have any errors. We can fix it, but I don't think so we should have. And let's run this and let's wait for it to process. Path doesn't exist. Entity. Okay, makes sense, because I didn't wrap this thing into a variable. Makes sense. Okay, now let's run this. Path does not exist. Entity. What do you mean? DBFS volumes. Source data. Okay, I think, oh, we forgot to wrap this thing as well. Okay, so let's do it, because this was a batch code and I can just do it. What's the issue? We didn't add F. That's it. It's minor things. And let's wait. And this cell, this alone one cell, will process our all the tables. Just imagine the power of this particular data. Basically, there's an error. What is the error? Let's see what is the error. Okay, is there any error or warning? Some streams terminated before command could finish. Okay, query, this is this, a schema mismatch detected when writing to the delta table. Okay, to enable schema migration using data frame writer or data frame writer, please select option not merge schema true. Okay, so let's first of all check the state, like what do we have currently. Let's open the bronze and we just have one table. Oh, I got it. I was so sure that, okay, something is wrong. We forgot to add here entity. So what actually happened? It created the table name with entity. And when it was just trying to create another table, obviously it will say, hey, schema mismatch is there. So it's fine. We can simply remove this table. It's fine. Or we can even delete it later on. It's fine. So let's run this code and silly mistake, just ignore. And I was saying that just imagine the power of this particular dynamic solution. If let's say you want to process hundreds of tables, or basically you want to create hundreds of tables, you do not need to copy and paste that cell 100 times. No, just one cell, 100 tables are done. This is the power and this is done. See, all the tables are processed and I can also show you the graph. This was the graph and currently it shows, basically this graph is just a representation of real-time data. This job is finished, so that is why we do not have anything in real time, but this is done. Let me just show you and refresh the page. Our bronze ingestion is done. It's done. Okay, if I open PySpark DBT, if I open bronze, oh man, yes, all these 6 tables are there. You will say 7. Bro, you need to ignore this one if you remember. So all these 6 tables are there, all these 6 delta tables are there, and we have enabled incremental logic using dynamic notebook, and you saw how we do it in the real world. So that is my point of creating this project as well, or basically all the projects that I create. See, I know there are a few people who love to criticize me. Thank you so much for doing that. It's fine. So even if someone says, hey, you are just building a project which is just a Kaggle using Kaggle dataset, this dataset, that dataset, bro, data engineering is not just about datasets. Data engineering is about solutions. Okay. So do not think like data engineering is just about dealing with messy dataset. No, it's about solutions. Okay. So I would say thank you so much for saying all those things. And I know like there are few people, that's it, but I love those people as well. And that's it. And I just want you to become aware of these things, that you can build these things with normal data sets as well. Yes. Okay. Makes sense. Okay. Very good. And just be positive. Just be positive. It's fine. It's fine. If someone is saying bad about you, just say, thank you. Thank you so much. Okay. So this was all about our bronze layer, and our bronze layer is ready. And if we just go and check our catalog, it will be having all the tables. And let's remove this entity table because we do not want to keep it. Okay. Just click here 3 dots and delete. Perfect. Our 6 data sets are there. And don't worry, you will also get all the notebooks in my GitHub repo so that you can refer it for your future use case, for your interviews, everything. But I would recommend you to create your own notebooks. Please, please, please. But I know sometimes you can feel, maybe not feel like, let's say you are just experiencing some errors. Then you can just refer those notebooks. Okay. So those notebooks are just for the reference, but please try to create your own notebooks because it will boost your knowledge and your confidence. Okay. Simple, sorted. Very good. Now let's try to create our silver layer. And now let's discuss like what we actually need to do in the silver layer. And we all know that silver layer means data transformation, data processing. But you know what? I will be showing you how you can create Python classes to automate the data transformation step. What? Another dynamic solution. Yes, another dynamic solution, because this thing can actually make a difference in your resume that we are going to do in the silver layer. Okay, makes sense. What's that? How we can just do that? What are the things that we will be doing it? Okay, let's see. So now let's talk about our silver layer. This silver layer will be special because you will learn a lot in the silver layer. Trust me. And you already know that PySpark is the basis of data transformation, right? So you will be learning a lot of things, including absurds as well. If you know about absurd, you should feel excited. If you do not know about absurd, then hold on, you will get to know. No worries at all. So let's first of all go to our workspace, and this is our project. Let's create our silver notebook. Okay, so let's call it as silver transformation. Perfect. So first of all, attach this notebook with this particular cluster. Perfect. So now we want to transform our data. In short, if we want to just define what is silver layer, basically transformation layer, where we just apply some transformations, we do cleaning, we do a lot of other things as well that we will just be telling in this particular section of the video. Okay, perfect. So this particular notebook will be handling all the data transformations that we know. And let me just plug in the mic. And let me check. It's working. Yes, it is working fine. So as we know that this notebook will be just processing all the data. Okay, perfect. And as I just told you that this notebook will be handling dynamic transformations as well. Make sense? And obviously like there will be like so many data objects within this notebook, that's for sure, but we will be handling some dynamic transformations as well. Perfect. So let's say we want to transform our data, which is, let's say how many, I think we have 6, right? So if I open bronze, we have 6 tables. Yeah, let's do one by one. Let's say I want to process first of all customers. Okay, so let's say H3 or let's say H4 and then make it bold. Then let's say customers. Makes sense? So we are just now processing customers. In order to process the customers data, okay, we will be first looking at the data. How does it look like? Okay, so I will simply say df equals spark.read. And this time I will simply say dot table because we have a delta table for it, and simply provide that delta table path, which is just the catalog name, schema name and table name. So catalog name is this PySpark DBT dot bronze dot customers. Make sense? Simple, sorted. And let's display the data as well. Or let's do it in the next cell. Perfect. So this will simply give us the data, not a big deal. Display df, and let's try to display the data as well. So as we know that each table is unique in terms of transformation. Makes sense? But there are some transformations which will be, oh, why it is null by the way. No returns, no rows returned. Wow. Why don't we have any data? Okay. We have all the things. Okay, so let me just provide any other thing, maybe this one. Okay, then let's see this data. Okay, this has data. Why customers doesn't have any data? Why customers? Okay, makes sense. Is something wrong with customers data? Is something wrong? Customers, because I can see the schema. Okay, no rows returned. Makes sense. Let's go to our bronze ingestion. Let's see what happened wrong. Okay, so if I open this catalog, if I open this thing, then bronze, then this is our volume, this is our checkpoint. We have everything for customers. Yes. So let's do one thing. Let's drop this particular directory called customers and let's refresh it. And what will happen after this? We will not be having any record for customers. Okay, makes sense. We have the label, but we do not have any kind of, you can say, checkpoint. Makes sense? So if I will be just running this particular notebook for one more time, it should give me that data. Makes sense? Yes, source data. And then I just want to make sure like the spelling is same, because that doesn't make any sense if the data is not added. There would be something maybe. So okay, volumes, this is checkpoint. And if I go to source, so we have customers, CUSTOMERS, CUSTOMERS. Everything is fine. Everything is fine. Let's try to process the data for one more time. Okay. And this will be a quick test as well for our incremental data load. So that is also good. So if I just show you the data for, let's say, drivers. Okay. So let's do our testing for incremental load. So if I say df.count, if I want to see like how many records do I have 50 records, right? If I now run this particular notebook for one more time, let's say this, how many records should I see in my drivers data frame? Should I see 100 or just 50? If our logic is right, if our implementation is right, then we should only see 50 records because we do not have any new file for drivers, right? If you see, our source doesn't have any new data. So that is the power of idempotency, which is there in our notebook. Make sense? Okay, very good. Now, in order for customers, we should see new data because we deleted the checkpoint for customers. So now Spark doesn't know if we have new data or not. So Spark will treat all the data as new data. Make sense? If everything is fine. Now let's try to see our customers for one more time. If it still shows 0, then obviously there's something wrong. Oh, now we have 200. Oh, it's perfect. Maybe there would be something wrong. Maybe typo something. Display df. Okay, now I have data. Okay, finally. See how you can just test your ingestion as well. So now you know like everything is fine in our ingestion logic because we are not seeing duplicates. Okay, we are just seeing the relevant data that we should see. Make sense? Just 50 records. Okay, and I can even show you in the driver. If you are seeing 100, that means you have done something wrong. If you see 50, that means everything is fine. Drivers or driver. Drivers or driver. What is the table name? Bronze. Drivers. Okay. Now let's see 50. Perfect. Our logic is fine. If you see 100, you have done something wrong. Okay. So this is our data frame. So now I was saying that there are some transformations which will be very, very customized and very subject to each entity, but there will be some transformations which will be applicable to all the data frames. Just let me know what are those transformations which are applicable to all the data frames, no matter what data frame you are processing. So the answer is deduplication, applying upserts. These kinds of transformations are subject to only and only, not only, to all the data frames. Make sense? So we'll be just handling how we can just apply the generic transformations, and instead of rewriting the code, because I don't like just performing static things, I love dynamic things. Make sense? So we'll be just creating Python classes for that and don't need to worry. So let's say I want to start with customers, and you will be learning a lot of PySpark functions as well. So don't need to worry. Let's say display df. Okay, perfect. We have 200 records. That's fine. So now within this customers table, we want to make it more enriched. Okay. And we want to basically transform it. Make sense? Okay. So first of all, the best thing about this is we already have the date time column in the desired format, which is a great thing. That's fine. But we every time add another column to our data frame that is like more another, you can say, generic transformation that should be applicable on all the data frames. What is that particular timestamp column? So basically that is called as processing timestamp. That means it will highlight the timestamp when that record was updated. Because in the real world, we need to see like when this record was updated, when this record was upserted. So by that timestamp, we just use to, like, you can say, filter out the records which are old or which are new. Make sense? So that is the power of that particular column that we use. Make sense? Okay. So that will be also added in our generic transformations. Make sense? But before generic transformation, we want to clean up a lot of things here. So here you can see that we have here this particular email column, this email column. So let's say we want to first of all clean this email. By obviously it is by default cleaned up, but we want to understand what are the domains of our customers so that we can just run our ads, anything. It totally depends upon the requirement, but we need to fetch the domains of our email IDs of our customers. Make sense? How we can just do that? For that, I will be using something called as, and let me just say it as dfcust just to make it more readable. Okay, perfect. dfcust. So I will be saying dfcust equals dfcust.with column, because this is a new column, and whenever we want to create a new column, we use with column. Okay. I will say domain. Okay, and I will apply a transformation called split function. What this function will do, this will split our column values into a list based on a delimiter. So I will say split on this column, which is called email. And what is a delimiter? Delimiter is @. Make sense? Perfect. Do you know what will happen? It will create a list of values, and each list will be having two values because there's only one split. So 0 and 1, 0 and 1, 0 and 1. That means in each list, there'll be just two elements. Now we will be just applying indexing because we do not want the first element of it. Just see, this is a list. Okay, just imagine this is a list and this is the first element. This is the second element. So we do not want the first name. For now, obviously you'll be just needing this in the future, but for now we just need the domain. Make sense? This is our domain. So I will simply getting which index? 1. Make sense? Because 0th index is this, 1th index is this. So we'll simply say apply the index of 1. Make sense? So this is our transformation, and you can even see it if you want to. Let's say display dfcust, and we can also import all the things like all the libraries and all from PySpark.sql.functions, import asterisk, and from PySpark.sql.types, import asterisk. Make sense? Good. So now if I just show you this particular thing, you will be able to see domain column, which is this one. See, domain. These are all the domains that I have, that we have literally extracted using PySpark. Make sense? So now if you just want to do next cleanup, what is the next cleanup that we want to do? So this is our phone number. Okay, and you can see that there are so many things which are actually not relevant here. For example, there are hyphens that we can remove. There are dots that we can remove. There are brackets that we can remove. There are basically so many things, right? +1 as well, we can remove. X as well. So we want to make this phone number clean so that we can actually use this column. Let's say we want to store the information in the right format. Make sense? Make sense? So how we can just do that? So first of all, you have a lot of options. Okay. One thing that you can do, you can use a function called regexp replace, where you can replace the values. Let's say you want to replace hyphen with nothing. You want to replace dot with nothing. So you have a lot of options that you can just do. But there's a more efficient way that I want to show you, and that is, so I will simply write dfcust equals dfcust dot with column. This time we do not want to create a new column, but we want to modify the existing column. So it is very simple. I can simply say phone number, which is the same name of the column, because I don't want to create a new column. So now what will be the transformation, or basically what will be the function we're gonna use? It is called regexp replace. So regexp underscore replace. So what we want to replace, and with what? So basically we want to replace everything which are not numbers. Okay, we simply want to replace everything which are not numbers. That's it. So I'll simply say list 0 to 9. These are my numbers, and I don't want to keep anything which is not a list. And where is that little cap, that reverse V? I'm just finding a key. Where is that? Oh man, where is that key? Oh yeah, 6. So these are basically the numbers 0 to 9, and we do not want to keep anything other than this. So I'll simply say, hey, replace all the unnecessary stuff with nothing. Do not even add a space, nothing. Okay, now let's see display dfcust. Perfect. What is saying? Missing one required position argument, replacement. Oh, we forgot to pass the column name, I guess. So I can simply say phone number, because we simply said, hey, just create this new column which is called phone number. But on which column we want to apply regexp replace? Obviously on phone number. Now it's fine. Now it's fine. See, so this is my new phone number column, which doesn't have any kind of, you can say, special characters, braces, dots, alphabets, nothing. But yes, some numbers will be longer because in some countries we have different extension codes that we have to follow and that we cannot reduce. Yes, you have to keep everything which is in the number format, okay? Because you do not know the rules of all the countries. Some have like 3 to 4 number of extensions, some have like 0 to 1. In our country we have +1, so it depends. Make sense? It depends. So now I also want to show you one more thing within this particular data frame, which is like subject to only this particular data frame. Let's say instead of having first name, last name, like these two separate columns, I don't want to just create many columns because I don't like to having unnecessary columns. So how you can just apply concatenation in PySpark? So it is very simple. So you will simply say dfcust equals dfcust dot with column, and this will be a new column, and you will say, let's say, full name. Okay, and here you can use concat function, but I personally like using concat ws function. So what it does, we simply define a delimiter, basically not delimiter, basically what will be the character that will be added automatically after concatenating two or more things. So I'll simply say just add a space, that's it. And what will be the function, like columns that I want to concatenate? First name and last name. Perfect. Make sense? Now let's say display dfcust, and I can also do one thing. I can remove df, basically I can drop if I do not want to keep first name and last name, because why do I need it now? Because I already have that particular full name, right? So this is my full name and I have dropped both the columns. Make sense? So that's how you can just drop the unnecessary columns as well if you do not want to keep it. Make sense? Okay, very good. So we have this particular data frame so far. Okay, so far. So now we can just talk about some generic transformations that I was just talking about in the beginning. Okay, so for that we will be just creating a class, a Python class, in which we will be just creating multiple functions which will be generic. One is deduplication for sure, that we're gonna do it right now. Second will be absurd, okay, and the third one will be what should we create in generic? The third function can be what was the function name that we talked about in the beginning? Okay, we will see. If we want to add more and more things, we can just add in that particular generic class. Okay, makes sense. Okay, so now let's create the class, but that class is special, right? And I want to keep that class as a utility. As a what? As a utility. So I can simply create a Python file here. I can simply say create, or I can even create a folder if I want to. So I will simply say folder, and the folder name will be, let's say, utilities, or basically utils. Okay, utils, simple. So this is my utils folder, and within that folder I will create my Python file, and I will name it as, let's say, custom utils.py. okay, so this is our Python file. But in order to access this file, you would need to do one thing in the beginning, that is adding the source path to the system path. What do I mean? So you would need to write something like this: import os, import sys. Okay, first of all import these two libraries, then you need to add this path. Which path? This one. This path to the system path. Make sense? And how you can just do that? Let me just show you. So first of all, you will simply say current directory equals os dot get current working directory. Okay, this is one way of doing it. If you will be using this particular function in Python, you can also say os dot, I guess, path dot absolute path. Okay, like this is the one, os dot path dot absolute path, and then you can simply say file, but this is a notebook, so it won't work here. So we will simply say get working directory. Make sense? So what it will do, it will simply give you the current working directory path. See, till PySpark DBT project. In some cases, it is not like mandatory thing, but sometimes you can see some errors while importing the module. So this is the workaround for that. You need to add this whole path in your system path. Make sense? So I'll simply say os dot, not os, basically system dot path dot append, and then you need to simply say current directory. Make sense? Current directory. So you need to append this path with this. So now this particular path is added in your notebook. Make sense? So now what you can do, you can literally write anything. Let's say I want to write variable 1 equals blah 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 blah. Okay. And if I want to use this variable, now I can just do that like this. Let's say I'll simply say from utils dot custom utils import variable 1. It's import. No module name called utils. Very good. So this is the error that I was just talking about, and I'm glad this error came. So this is the error that it is saying, hey, you need to just say what is the utility name. Okay, and we have literally ran this particular append function. Okay, so simply reset your cluster. Okay, and then you need to simply add this thing. So once it is reset, then it will take some time to start, maybe a few seconds. Done. Then you can simply add it like this. Okay, perfect. Then simply run this. Now if you will just try to read this file, it should work. See, now it worked. So you can simply say variable 1. So this is the value. Make sense? So one thing is you have to add this utility. Okay, this utility's path in your system path, and then you can just use it. If you are seeing this error and you are not able to do this, no need to worry. This was just, you can say, a best practice. But sometimes if you want to just go with the flow and you are seeing the errors and you do not want to keep on seeing the errors, simply create the class that I'll be creating in this particular Python file. In here, you can simply create the class here at the top of your Python file, because once you have that particular class in your notebook, you do not need to just go anywhere else to import it. Okay, but I just wanted to show you the best practice as well. But sometimes, yes, I can feel your pain. Let's say you are not able to just get rid of the error. Fine, simply copy the class and paste it in your notebook, and that's it. Because your aim is to learn how to create the classes, not just to figure out like how to import the classes, right? That's just a best practice. Okay, makes sense. Now let's create a class. So I want to create a class. Let's say create class, and class name will be transformations. Okay, transformations, makes sense. So within this class, if you have some fundamental understanding, we first of all create, you can say, some class variables which are called as attributes. But I don't want to create any attribute because each function will be unique. Okay, so here what I can do, I can simply say def, and I want to create a function called dedupe. Make sense? And within the class, one thing that we always define is the self parameter. Make sense? And this dedupe function will obviously accept data frame, plus it will also look for the list of columns on which we need to apply the deduplication. Make sense? Like on which column we need to apply the deduplication. Let's say we want to apply deduplication on one column. We can also apply deduplication on 2 columns, 3 columns, 4 columns, and so on, right? So we will simply say dedupe columns. Perfect. And this can be a list, right? And we can import list from typing import list. Okay. And this will be a list basically. And this will be a data frame. And I can say from PySpark.sql import data frame. Okay, so df will be data frame. Okay, makes sense. And self is just self variable, so it's fine. So whenever you want to perform deduplication, what do we do? we simply use something called as window function. Okay, and dedupe is like a very generic function or basically transformation that you will do in almost all the data frames. So for that, I will simply say df equals df dot with column. Okay, and we will be creating a column called dedupe. Dedupe basically, let's say dedupe key. Yes, let's create dedupe key. And what this column will do, this column will first of all create a hash column based on all the columns that you have provided here in the dedupe columns. Make sense? So this will be the hashing of all the columns that you have provided in the list. Very good. So how you can just get the list? Very easy. You can simply say dedupe list. Okay. And do you know what? You can even get this particular list in the form of string. Really? Yes. And you can just convert it into a list using eval method. So it is very easy. But let's keep it a list, or let's keep it a string, or it's fine. Okay. You should learn new things. Okay. So now this will be a list. Okay. And how we can just define that particular thing? And you already know we'll be using concat. Make sense? And what will be the column names? Column names will be a list of dedupe columns. Now, what is this asterisk that I have used here? What is this thing? Whenever we want to work with, let's say, PySpark transformations, okay, and we have some Python classes or basically any Python capability that you want to use. So this is a list. And in the concat, we simply pass what? We simply pass the column names in the form of string. But this particular list can be unpacked using this asterisk. Make sense? Using this asterisk. So we can simply unpack anything using asterisk. So now what it will do, it will create a dedupe key and it will be the combination of all the columns. Perfect. That is fine. Once it is done, then you will simply say df dot with column, basically df equals df dot with column. And I want to create basically the dedupe counts. Like how many duplicates do we have? Dedupe counts, right? Dedupe counts, and it will be a kind of window function. So let's import that as well from PySpark dot, I guess, SQL dot window, import window. Okay, makes sense. Import window. So now if I want to say row number, okay, row number dot over, and now what we need to use in the window? Obviously dedupe key, right? Window dot what? We will want to say partition by on dedupe key. Fundamentals of window functions. You should know about window functions. So basically row number is a function that we use to eliminate the duplicates. Make sense? So we are simply applying a grouping of key columns so that whenever we have any new record for basically any more record for that particular grouping, it will simply say, hey, the count is 2. Otherwise it will say count is 3. Simple. Do we need to apply any kind of order by? We can. Yes, we can. And what should be the column name? Because obviously if we are simply getting, let's say, more and more records, and if we have some duplicates, so we should be deciding on any column, let's say what column we should pick for deduplication, right? In some scenarios it can be date column, in some scenarios it can be anything. So I will simply ask for that particular column from the user. Simple. So that column will be this one, last updated timestamp. Okay. And I will simply ask this one as well. I will simply say CDC. Okay. CDC, and it will be string type. Okay. So here I can say dot partition by, and now then dot order by. Okay. We want to apply order by. Make sense? So here I can simply say CDC. Okay. So once it is done, I just need to filter all the records which are duplicates. and I will simply say column dedupe counts equals to 1. That's all. And if we have any duplicate 2, 3, 4, simply remove it. Okay. And now at the end, I can say df equals df dot drop, and let's drop dedupe key because we do not want this column, and dedupe counts. Make sense? Dedupe counts. Perfect. And at the end, return df. So this is a code for applying deduplication. And obviously this is a very generic transformation that you want to apply on all the transformations, and we do not want to write this particular code again and again statically. We will simply write this code one time, okay, in a class, so that we can just reuse it every time. Make sense? So let's try to test it. First of all, I will simply import all the things in my notebook as well. Perfect. Let's run this. Data frame cannot import name data frame. Okay. Maybe it is capital F. Okay, perfect. It is capital F. Let me just change it here as well. This is just the type ending. Okay. Okay, so now let's test it. And I will simply say from util.utils import transformations. Okay, let's run this. No module named util. Oh man, let's do it one more time. Let's simply add that path here, or let's actually move it out. So if I say move, or let's put it inside this particular project only. Okay, makes sense. And let's delete this particular folder, because I think then we do not need to just define it again and again. And you can simply say from utils import transformations. I think so. From utils, is it transformations or transformation? Transformations. Okay. Okay, it is same. Cannot import transformations from utils. Unknown location. What? Or if I say import, oh, it is custom utils. Okay, from custom utils import transformations. No module name, custom utils. Okay, we have to just maybe let's copy and paste that particular utility in this one, because I don't want to run that particular thing again and again. Because I'll be just turning it off, then importing it, then doing it, then blah 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 blah. I don't like it. So let me just grab this particular class here in my notebook, or instead of creating the Python file, I can also create something called as notebook, but it is fine. Let's get rid of this. So I'm giving you the company, so let's stick with only one approach. Okay, perfect. So let's actually run this class. It's fine. Now what we need to do, we'll simply say we want to test this particular class, right? So I will simply create an object of this. I will say custom, or basically customers object equals transformations. Okay, because this is the class I want to use. Makes sense. Now for this particular object, I want to use customer object dot dedupe. Okay, so here I need to just pass all the parameters. So first parameter is data frame, then I have the list of key columns, and in this case it is customer ID, I guess. Makes sense. Then I have last updated timestamp. Makes sense. So now let's say custom df transform. Okay, and then let's see what will happen if I just display this custom df transform. Okay, let's display it. Make sense. Let's see. df customer is not defined. Okay, so maybe we need to just simply run all the cells, because we didn't run this because of restarting it. So let's say run everything. So let's wait. So this is running. Okay. Okay, this is done. This is done. Okay, so perfect. So our class is also running fine. As you can see that our data frame is deduped and everything is running fine. Everything is perfect. And we do not need to worry about anything here. As you can see that this is deduplicated. Makes sense? Obviously, we didn't have any kind of duplications, but if we do have, it will be automatically gone. Make sense? So this is our data frame that is ready to go. Make sense? Which is ready to go. So what I can do now, we can just try to add the absurd logic. What we can do, try to add the absurd logic, and before that you need to understand the absurd command. Basically, let me just tell you what is that. So absurds are very simple but are tricky, and you need to understand like why and what you need to do. So basically, let's say you have your source, okay, and you have your destination target table. Let's say this data, basically this source has data like this. Let's say 1 2 3. Make sense? This will be loaded here 1 2 3. Next day, this source data has some more records. Let's say 4 5 and 1 and 2. Obviously, let's say there's a change in 2, so and 1 as well. So there are some new records for 4 5 1 2. Make sense? So what will happen in the target table? It will become 4 5. Now in the target table, which is our silver layer, we cannot store duplicates, as you know. So what we will be doing here, because we also want updated data 1 and 2. That's why we have a concept of called absurd. So this absurd will simply say if you have any new data, it will insert it. If you have any old data but with updates with new values, so it will simply take the values and it will update it. So this will be updated with these new record with these two values. Simple. And this way we will not be having any kind of, you can say, duplicates. Plus we will be having updated data all the time. Make sense? Make sense? Make sense? Make sense? Very good. So now one thing which is very important. What is that thing? Basically, let's say you are loading all the data. Okay. And in this case, you are loading all the data in the silver layer, right? You are not loading only the incremental data because you are reading all the data which is available in the bronze layer. Yes. Makes sense? So now you will be having 1 and 2 here as well and 1 and 2 here as well. So there will be duplicate. Make sense? That is why we provided, if you remember our code for class, we provided order by based on CDC. Based on what? CDC. And obviously here as well. So basically we have rewritten this particular class, and just for your reference, I just copied and pasted the class here if you see the errors, and I also pasted the code here as well if you just want to refer this notebook, so that in this particular notebook you'll be having both the ways, if you want to import this file or if you just want to directly use the class. That's it. And just to make a distinction, I have added extra s here, okay, so that you would know, okay, this is like coming from the Python file, and here as well as double s. Make sense? Okay, good. So this is done. So now we were just saying that that's why we have added this particular order by command in this CDC. Make sense? So what it will do, it will only and only deduplicate the data based on the latest date. And if you are smart, if you have some common sense, we have made a silly mistake. We have simply provided order by. See, we have simply provided order by. Let me just first of all make this in the next line so that it will be more readable. Perfect. Okay, so this is order by. But if you remember, we need to fetch the latest data, not the previous data. So here we should be writing something called as order by or sorting based on the descending order, not in the ascending order, because by default order by will work in the ascending order, right? So we can simply say dot desc, or basically we can write here as well desc and then like this. Make sense? And it is saying order by red. Why? Maybe we can just remove DSC from here and we can add it here as well. Dot DSC. Simple, simple. Now, just to make sure, let's run the code for one more time. Okay, let's see like everything is fine. So I can simply do it like this. And let's see if everything is fine. Okay. Windows specification object has no attribute DESC. Okay. So it is saying it is not running fine with DESC. Okay. Dot order by. Okay, makes sense. I think we can just remove it from here then, because this is inside the window function. And if we are inside the window function, then obviously we need to use maybe something like this. Let's try this one. So just write here DESC like this and everything should be fine. And let me just update the code here as well. Order by DESC of CDC. Perfect. Perfect, perfect, perfect. And now let's run the whole code for one more time. Let's see if it works. Because that is the one of the most important steps that we have. Order by on the latest date. Otherwise you like it will not create any problem, but to build a robust solution that even if you perform backdated refresh, it will not cause any problem. Okay. So let's say we want to apply the upsert and let's do it. And this is our deduplicated data. Perfect. So if you want to just apply upsert, I will simply say upsert here. Have we defined any kind of heading? No, it's fine. So I'll simply say df equals, or even not even before like df, we want to simply say if we do not have any kind of data sitting in our table, then we first of all need to create the table, right? So I'll simply say if spark.catalog.table exist. And what is the definition for table? It is simple PySpark DBT silver.customers, because you want to write in the silvers table, right? So I'll simply say if that table is not there, then first of all create the table. So I'll simply say tf.write.format, and format will be delta. Then dot mode can be, let's say, append, and it doesn't matter because this is just like one-time load. That's it. Then not option, I will simply say dot save as table, PySpark dbt.silver.customers, and we have not created any kind of, you can say, silver schema. So let's quickly create that. So I can simply duplicate the tab and let's go to catalog and let's create our silver schema. So PySpark, okay, create schema, and this will be called silver. Okay, perfect, create, that's it. So our schema is also ready. Okay, so this is our table that we want to create. Mode is fine, save as table is fine, and that's it. So this will simply write the data. Makes sense. But if our table is there, then how we need to tackle the upsert, basically the merge command. This is the main thing. So basically, if you remember, I told you that we also want to create a function which is very generic and that will define basically the process date. Did we add any kind of process date? No. So we should add that particular process date. And instead of creating static function, I will simply create a dynamic function here. So this will be called as def, and then let's say process timestamp. Okay, this will take self and this will take data frame, simple. And this will return basically df equals df.with column, and this will create, let's say, process timestamp. Make sense? And this will be nothing but just the current timestamp. That's it. Current timestamp, and that's it. and return df. Perfect. Makes sense. Let's run this. Okay. So now I can just simply use this particular transformation as well. After, you can say this one, after basically this one, when we just deduplicated the data. Okay. So once we have deduplicated the data, let's try to add that particular column. And it's very simple. Cust object dot process timestamp, and current timestamp is this one. And let's see if we have, it is saying that it has no attribute process timestamp. Okay. Cust object equals dot process timestamp. Okay. And where is the cust object? Cust object is, where is our cust object? Okay. Cust object, this one, transformations. Okay, makes sense. Transformations, process timestamp, and everything's fine. So let me just process this one more time, and let me just remove these outputs, because this creates view very messy once the code is built. Okay, perfect. Okay, then we can just see this. Okay, now let's run it one more time. Now let's see what is the issue. Okay, it worked. Okay, it's fine. And obviously this was not completed, so that's why it is just doing this thing. Incomplete input. Yes, it's fine. So now here we should see that column, which is process timestamp, which is today's timestamp, basically current timestamp. Makes sense. So this is our timestamp column. That is fine. But now what we need to do, we will simply say else, and we will also import some special libraries. It's called from delta.tables, import delta table. Okay, so this is basically the library that we want to import. And do you know what? I want to make this dynamic as well. Really? Yes, let's do it. It will be challenging, but let's do it. That's how you learn, right? That's how you learn. Let's do it here in our class. Okay, in our class, let's remove the spaces. Okay, so let's create another function which is called upsert. So for upsert function, we just need self and df and key columns. Key columns, obviously. Makes sense? Okay, key columns. So how we will be just doing it? We will first of all using delta.tables import delta table, because this will be our object. So we'll simply say dlt object equals delta table dot for path. We can also say for name, it's fine. And you can also say for path, it's up to you. Let's call it as for name because it will be easier. Okay. And now we can simply say PySpark dot silver dot customers, right? And if you just want to make it dynamic, let's take the table name as well. Okay, table name, and let's make it dynamic. Let's add F command and let's call it as table. Make sense? Table, simple. So this is our delta object that we have created on top of destination table, because see, you need to imagine this. So once your data is loaded in the initial run, in the first if command, right? Now what you need to do, you need to simply apply the upsert. And when you apply the upsert, you basically need to merge it with something. Make sense? You need to merge it with something. So if you want to merge it with something, you already have a source, which is df cust. You need to create the target data frame so that you can just merge both of them, similar to join. Make sense? So I'll simply say dlt object dot alias, and I will give it as alias as trg, which is target, then dot merge, and I want to merge it with df. Make sense? Which is the source input. Okay. And then I will say df dot alias. It will be called as source. Make sense? So this is a merge command. What will be the condition? What will be the condition? This is very important, and this is like something that you need to, you can say, make it dynamic. So how you can just do that? So basically Here you need to dynamically create the merge condition dynamically. So you have key columns, right? You have key columns. Here you will be using your Python skills where you will be using list comprehension. So I will simply say merge condition equals, first of all, I will create simply the list, and list is basically key columns, right? So let's say I have key columns here as customer ID, then so on, right? So I'll simply say for I in key columns. Okay, and what will be the output of this? The output will be f string, which will say source dot I, that means column, equals trg dot I, that means column. That's it. This is the thing that I want to return. So this will be a kind of list, and I want to unpack this list using dot join method. Okay, dot join, because I want to just create a string from this list. Okay, and what will be the delimiter? It will be nothing but and. Simple. If we have, let's say, more than one list comprehension things, you need to process it in your mind, and I know this is a little bit challenging, but it is good for your growth. You need to see like how we need to just build dynamic solutions. Make sense? Because once these solutions are built, then you simply need to use it instead of just writing the code again and again and again. Make sense? So here I can simply say merge condition. That's it. And it is dynamic, pure dynamic. I don't need to hard code anything. No, I will simply define key columns list and that's it. Boom. I do not need to worry about any kind of manual code. See how powerful it is? Yes. So this is your, you can say, upsert command. Okay, this is like merge condition. So once merge condition is also applied, then we will simply say dot when matched, then update all, when not matched, then insert all. Make sense? And then obviously at the end dot execute, and that's it. This is your upsert logic. Simple. No need to return anything. But obviously if we are using function, we can return something. Let's say return, let's say done. Okay, or let's say return 1. Anything. Make sense? Okay, so now in the update command as well, you can use one condition. It's up to you. Okay, it will make your code more robust. So what should be the command? So let's say you are doing a backdated refresh. Okay, and you do not want to update the data based on, you can say, your old data. Does that make any sense? Let's say you are simply applying an upsert logic. Make sense? And in your end table, you have value for id equals to 1 equals to, let's say, pen. Okay, pen. And this is recently updated. But due to some reasons, you applied a backdated refresh on your source table, and now you are getting the previous value of your id equals to 1, which is pencil. So would you like to update that value with the previous value? Obviously no. So you should add a condition here. Condition equals, and here we will simply say source dot last updated timestamp. Basically it can be literally anything, but in our case it is last updated timestamp. Last updated timestamp greater than, or basically should be equals to as well, not just greater than. Should be greater than or equals to last updated timestamp. Now you will see, now you will say, hey, will it be same in all the cases? Obviously no. Obviously no. So that's why I will create a variable .cdc, and here as well .cdc. Perfect. And I will get the cdc from my user. This is my function upsert. Let's run this. Perfect. So now let's actually use this function. So see how clean our code is looking right now. We need to simply say cust object. We already have cust object, as you know. I'll simply say cust object dot upsert, and I will simply pass df cust. Okay, and customer ID and customer's name and last updated date. Make sense? And here it is df cust as well. So easy, so simple, so neat and clean code, because all the processing is here in our class. that you can obviously import it, and I can also just copy and paste it here, the updated, you can say, code, because we made a lot of changes. Okay, perfect. And let's just rename it transformations double S, just to make a distinction. Perfect. So that is our code. So that's how you keep your notebook, the main notebook, neat and clean. Okay, so now let's actually run this particular thing. If and else. Okay, now it should work fine. So first of all, what it will do, transformation object has no attribute upsert. Oh man, we simply need to rerun everything. I think so, because cust object dot upsert, and we have just defined this upsert. Yes. And the thing is, we also need to update our this thing, cust object, because this was created like long way back, right? So let's reprocess everything. And now it is saying table or view name, delta table dot for name. Oh, makes sense. We forgot to write here Spark, that we always define. Okay. So, okay, perfect. Let's see. So this time deprecated. DB name has been deprecated since 3.4 and might be removed in a future version. Use table exist DB name dot table name. Oh, really? Really? This is deprecated. Okay. This is basically a kind of warning, so you do not need to worry about that. So it is saying use table exist DB name dot table name. Okay. Future warning, DB name has been deprecated since this one. Okay, so now it is saying just use this one. Okay, but we are using catalog as well. That's why I like using, you can say, table name dot for path, but it is what it is. Spark dot catalog dot table exist. Okay, so is it a kind of error or warning? Let me just check if it has created our silver layer, because I think in Spark 4.0 there are so many changes. Okay, so this is an error. This is not a warning. Databricks Python library. Okay. DB name has been deprecated. Use table exists. DB name dot table name. Okay. We can use DB name dot table name, but let me just click on diagnose error. Oh, it's fine. Let me just check. Wait. I think. Wait. Why did I pass Spark here? Why? Wait. We didn't need to pass Spark here, because Spark we pass it there, like when we create the delta object. I was like, what? Okay, so it is saying delta table dot format missing one required position argument, table or view name. Okay, delta table dot for name. Okay, so we need to just correct it in the class, not here. So in the delta object, DLT object, yeah, here we need to pass Spark. I was like, wait, did I make any mistake? So here we need to add Spark. Okay, makes sense. Let's rerun it, because we never create basically any kind of catalog object using Spark variable. So let's see if it is working fine. So it is saying silver.customers is not a delta table. Okay, makes sense. Oh, I was like, why it is going directly to the else? Because we need to say if not then, because if table is not there, then it will be running if command first of all, and then it will go to the second command. Perfect. That's what it should do. So first of all, it will create the table. That means this command. Make sense? Then once it is done, then it will write the upsert command. So I think it should have done that. Let's refresh and check it. Silver, and then yeah, customer table is there. Let's try to query the table. Select basically count. Let's see count asterisk from PySpark DBT silver dot customers. Perfect. Let's see 200. Perfect. Let me just run this code for one more time, and I should see only 200 records instead of 400, because we have here upsert logic. Okay. Now it is saying silver dot customers is not a delta table. Okay. So what we have done there? Silver dot. Okay. So where is our delta object? PySpark. Oh, it's not PySpark. It's called PySpark DBT. Okay. Now let's run it one more time. So Now what's the error, bro? What's the error? I think we have used something extra. Any braces, anything? Okay. It was saying like there's an additional curly brace. Oh, silly mistake. We forgot to add F here. I was like, where did we miss curly braces? Let's hope for the best. Oh, this view is so good, right? See, on the right hand side, they have just added all the green, and this is a kind of loading step. Nice. So, okay. Oh, by the way, very well done. All the records are completed now, and you can see like 200 records. Okay, so that means our upsert logic is perfect, and we do not need to worry about any kind of thing. Our upsert, or basically merge condition, is perfect. So this is done. Now what do we need to do? We need to process all the tables similarly. Okay, so let me just open another table that we have in the bronze. So next table that we have is, let's say, drivers. Let's try to cover that one. Drivers, and yeah, perfect. So let's say drivers, and if we just create a driver data frame, df dot spark dot read dot table, and then drivers, and let's try to see driver. And it's your homework as well. If you want to add more and more functions in your class, you can, and you should, if they are generic and if they're applicable to all the data frames. Okay, so far we just have 3 functions, and if we will find more, we can just do that. Make sense? So these are drivers. Okay, and we have similar transformations for drivers as well that we have for customers. Why? Because customers are also human beings, drivers are also human beings, right? So we have first name, last name, phone number, all those things similar to this one. Make sense? Very good. So let me just copy and paste the transformations for drivers, and it will save us a lot of time that we can do. Okay, makes sense? Okay, makes sense. So let me just grab the code. So first of all, we can just clean our phone number. Okay, and then you will simply create the full name and last name. Make sense? So this is my driver, and make sure that you update the data frame name, otherwise it can create a mess. Driver. Okay, and let's run this cell. Okay, this is perfect. Now let's process our first name and last name. Make sense? Perfect. Okay, so let's call it as driver. Perfect. So this is also done. Let's run this. Now we will be creating, or basically using, our generic functions, and see, this will save us a lot of time plus efforts, plus you can literally process as many tables as you can. Do not need to rewrite the same code again and again. So I can simply say driver object equals transformations. Perfect. So this is my object, driver object. Make sense? So first of all, obviously I would like to dedupe my data frame. So I will say driver object equals driver, not object, basically df driver equals driver object dot I can also run process timestamp, okay, before deduplication, but it's fine if you just apply deduplication. So I'll simply say deduplication, and I want to apply dedupe, and what will be the you can say parameters, obviously df, then key columns, then last timestamp. Just these 3. Make sense? Just these 3, or we can just check if there are more parameters in our class. So we have 1, 2, 3, and then we also have CDC. CDC is also there. Okay, we have provided CDC. So what else? Data frame, dedupe, list. Wait, data frame, list, CDC. Yeah, just three. It's fine, just 3. Okay, makes sense. This is our first transformation. Okay, perfect. Now I can say df driver equals driver object dot, I want to apply, let's say, process timestamp. Okay, I will simply provide this df server, df basically driver. Make sense. Now I want to apply upsert. So now I can simply say if not spark.catalog.table exists, same step that we have done there. Okay, this will be drivers, else I want to simply apply upsert. Make sense? Simply upsert. Okay, makes sense. And we have the unique key as driver ID, as you can see. Perfect. So this is our command that I can just run now. Okay. And this will first of all create the table, and then it will upsert if I want to reprocess it like this, just to test my upsert logic. Okay, and just to make sure everything is fine, I can say select count of asterisks from DBT silver drivers. Perfect. Okay, 50 count. Perfect. Now let's process our, see how quickly we can just develop. So it's like one-time effort that you do and everything will be dynamic in future. Then you just need to just use those things instead of developing each thing from scratch. Just imagine you would be rewriting your upsert logic, your deduplication logic, your process timestamp logic, everything. Just imagine the hard work you need to do. Makes sense? That's how you build the real world solutions. Okay, so now let's try to work with another table, another source basically, which is locations. Okay, now let's try to work with locations. So df location equals spark.read.format, and I hope like you are understanding a lot of things. And even if you do not understand all the things, just rewatch the segments of the videos because that are important to absorb the knowledge. Understanding the concept is one thing. Doing the thing is another thing that you need to do. And third thing is take notes. You have to follow all the 3 steps. A lot of you will say, hey, my step 1 is done. I have understood the thing. Okay, it's fine. No, you have to do it. You have to build it. And once you have built it, you need to take notes so that you can just remember those things. Otherwise, you will forget everything in just 1 week. Trust me. Even if you have done that, up to you how you need to just do. Okay. PySpark DBT location, basically locations. Display df loc. So here we have locations. Okay, and this data frame is actually very clean because this is like locations data and we do not have anything to perform here. So what I will do, I will keep it as it is and we will simply apply our generic transformations and that's it. Okay. And obviously it's like a play game that you need to do and that you can also play it with your data frame. You can just add more and more transformation as you like, but obviously we need to cover all the things, right, in the given interval of time. So I will feel really happy if you'll be just applying more and more transformations on your own, just for the, you can say, learning purpose. That's it. You can maybe concat, you can just transform the column into uppercase. Okay, good. So I will simply create an object called location, or basically log object. And if you are learning a lot, if you are learning new things, if you didn't know about these things, just drop a lovely comment in the comment section. This will literally help me a lot. I literally feel happy, and I will see, if you want me to continue creating with these kinds of videos, I should know, right? So just let me know in the comment section. Just let me know. Okay, makes sense. transformations. Okay. So this is our object. Let's apply df lock equals df lock, or basically lock object dot dedupe. Okay, let's dedupe it, and we can also say process timestamp. Makes sense. So let's apply both the transformations together. Perfect. And now upsert. If not, spark.catalog.table exist. Perfect. And else upsert. Perfect. Let's run this. Perfect. And let's run it for one more time, just to see our upsert logic is working fine for locations, because see, every table is unique, right? So that is why. Select collect asterisks from perfect. Very good. Now let's process our fourth table, which is called payments. Perfect. Payments. And you know what? I know that you have learned a lot in the silver layer. I know that you have learned about classes, dynamic solutions, everything dynamic. I know. Do you know what? Our gold layer is even more interesting because it is related to DBT. In the DBT, we will be just creating our story changing dimensions, everything there in DBT, and it will be a lot of fun. Trust me. A lot of fun. And you will literally learn a lot. Okay. So payment is also, let's do the payment. df pay equals spark dot read dot table. Okay, and let's first of all display it. Display df pay. Perfect. Payments, not pay. Okay, so this is very interesting because this is related to, you can say, your payments, all the things. And I can say that we have almost all the clean data, but I want to just introduce one cool transformation that will be very handy for you. Let's say you want to apply case statements in PySpark. Let's try to learn that using this example, right? So let's say if if you have just two status, right? Success or failed, or I think it will be one more like pending. Yeah, 3: success, failed, and pending. And you have your cash payment method, okay, wallet, and card. Card is very critical. Okay, so you want to create another column which will be specifically built for card, and you need to say if the payment method is card and payment method is status, then say success. If it is pending, then pending. If it is failed, then failed. And it will be just for card. And if there is any other value, then it will say other. Make sense? So it will be like online payment. You need to create a column called online payment based on these conditions. Let's try to do that. So I'll simply say df pay equals df pay dot with column and column name will be online payment status. Make sense? And here what I will do, I will simply say when column of you can say payment method equals to online, basically card, payment method equals to card. Make sense? Like this is like one condition. Okay, then I will say ampersand column payment method, or basically status, I guess. Payment status, yes. Payment status equals to success. These are basically two conditions. See, condition number 1, condition number 2. And just for the better understanding, you should encapsulate these things in the braces. It is a kind of BOD mass rule. Okay. Similar to that. Okay, makes sense. So this is this one. If it is true, if when this condition is true, then you can simply define what you need to do. So see, this is condition number 1. Okay, this is condition number 1 and this is condition number 1. See, so who wrapped this function like this? This is my first condition. Okay, there should be no closing braces like this. Then this is my second condition, like this. Okay, like this. Okay, this is my second condition. If it is true, like this is like see, let me just move it here. So this is my first condition. When and this makes sense, we have literally wrapped this function. Okay, and we can remove this extra brace from here. Perfect. So this is my second condition. If this is true, if both the conditions are true, so we will simply wrap both the conditions into a new braces. If it is true, then I will say, let's say online success. Make sense? Online success. If it is true. Make sense? Make sense? I know this is tricky, but it is good. Okay. Make sense. So this is my only this column, when. Okay. This is just my when column. Okay. Now I want to say this is just like one condition. Then I will write another when. Okay, I will say dot when this is equals to card and failed, then it will be called as online failed. Make sense? Good. Then I will say these are the two things. I have another thing which is called pending. So I can simply copy and paste it from here. And I will simply say pending. And I will call it as online pending. Okay, makes sense. When all the three are checked, if we have any other case, then I will simply say dot otherwise. Make sense? Dot otherwise. Simply say offline. Simple. Make sense? Now let's try to look at the output. Display df pay. Let's try to see. Okay, so here you can see offline and online failed because this is a card payment and it was failed, and this should be failed as well. This should be pending. Let's test it. See, online pending. So that's how you can just work with case when statements in your data frame, in your PySpark data frame. Make sense? Make sense? Okay, very good. So that's how you can just work with those things. Once you are done with this, let's create our, that class objects. Let's do that. So basically I'll simply say payment object equals to transformations, and I want to dedupe it. I want to process it. And once I'm done with those things, then I will simply say if not spark dot catalog dot table exists delta payments else absurd. See, are you focusing on the power of dynamic code? It is just like now applying this particular one line of code. Otherwise I would have been writing same lines of code like multiple times. Make sense? Make sense? Okay, so this is also done. Make sense? This is also done. So now let's try to query it. Select count asterisk from silver dot payments, and here PySpark DBT. Oops. Silver. Perfect. So 1000 records. Perfect. 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 So now our almost all the tables are done. How many are left? If I check bronze, I think we have two left, trips and vehicles. I will just show you only one, because one I will just show you in the DBT, because I want to show you how you can just incrementally apply the upserts using DBT, because that's a great package for that. And that is why one thing will be transformed there in the DBT. That's how you will be learn more and more things in DBT. Other than just building the gold layer, we will also build one table of silver layer. Make sense? Okay, very good. So let's try to create, let's say, vehicles. Make sense? And trips is our fact table. So we will be simply creating fact table silver layer in the DBT, because fact table are big tables. So we need to just incrementally load the data. We can also apply the logic here, but I want you to learn DBT as well, more and more in depth, because gold layer will be very much in depth, I know, but yes, more and more things. Okay, so let's try to do it for vehicles. Okay, let's try to do it for vehicles. Vehicles, I will simply say df vehicle spark.read.table display df. Let's see if we have anything to apply. Okay, license plate, vehicle ID, make, year, vehicle type, and last updated timestamp. Okay, looks good. Model is this is the license plate. I think everything is fine. One thing I would like to do it, like make. Let's try to, or basically you can say model, because model should be highlighted in the data frames. Make sense? Because models are like very few and we should be able to highlight this thing. So I would like to make it in uppercase. And how we can just do that? It's very simple. df equals basically df vehicle dot with column. Okay, and I will simply say make, and I will use upper transformations. Okay, upper transformation and column of make. That's it. Make sense? Just make. And if I say display df vehicle, you will see that our make is now uppercase. See, make. We can also convert model, but yeah, make is important. Make sense? Make sense. Yeah. So yeah, perfect. So now let's create vehicle object. Same thing, process timestamp, and let's try to do it in this. If not, spark.catalog, append, else. Perfect. Let's actually shift it to a new code. Perfect. And let's see the count. Select count of asterisks from silver dot basically PySpark DBT dot silver dot vehicles 50. Now let's try to run this one more time, and this should have done exactly 50 if everything is fine. Perfect. Our notebook is completed. Well done. Well done, my data fam. Well done. Well done. So our silver notebook is ready, which is full of transformations, full of dynamic, basically classes. Can you imagine? Can you imagine? And don't worry, I'll just upload this notebook. So just enjoy with this notebook and just play with this. And I know that you have learned a lot in the silver layer. That was my agenda since the beginning, that I want to show you classes, upserts, all those generic transformations. And I'm really happy that you learned how to work with Spark structure streaming dynamically. So that's another amazing thing. So yeah, these are some of the things that you can just work with, and these are really helpful. So this was all about our PySpark coding. Now we gonna work with our DBT. Are you ready for DBT? Because it will be amazing segment of the video. So now let's see how we can just work with DBT. And if you want to learn about DBT, because I would expect some of the knowledge in DBT before jumping on the DBT part. If you do not have any knowledge, so I don't know what you are doing, bro, because I've already launched the detailed video on DBT. Just search DBT Masterclass and just say Ansh Lamba, because this is the DBT. I told DBT. It is saying data modeling. Wow. Just go on YouTube and just say DBT Ansh Lamba. See, this is the video DBT Masterclass, and this is like 5 hours long video and amazing masterclass that has covered DBT from scratch. So you can literally learn everything including CI/CD. So just go and watch that DBT video, and I will just try to include the video link as well so that you can just go and check it out. Make sense? So I would expect some of the knowledge in DBT, and let's try to actually perform all the things in DBT. Just for your information, we'll be using DBT Cloud version, which is free. Okay. Plus it is very easy to manage. Plus it is very easy to directly get started. So we'll be simply learning DBT Cloud. And obviously if you are just looking for cracking the interviews, DBT Cloud is a thing that you should know, because everything is on cloud right now. Makes sense? So we will be simply establishing everything on DBT Cloud. Let's do it. Now we're going to talk about DBT. So what is DBT? Basically, DBT is a data build tool which is designed to make your code more modular, and which can be, like, you can say, take the overhead of just managing all the transformations. Understood anything? No, I know that. So basically, DBT, first of all, is very much in demand. Open source software, obviously the managed software is also there, but overall DBT is compatible with all the things, basically all the cloud, Azure, GCP, AWS. Okay, so you can just target any job. Then DBT is even compatible with all the kinds of, you can say, data platforms such as Fabric, Databricks, Snowflake, so many platforms, right? So DBT is like game-changing thing. DBT is an amazing tool. Plus DBT can handle your code modularity, and you will see all those things, don't need to worry. And how it manages code modularity, everything we will just see. Don't worry, because we learn by doing it. Again, there's a detailed 5 hours long tutorial, and you can imagine like what you will learn under 5 hours. So you will learn almost everything of DBT, including deployment. So you can just watch that video that I have just mentioned. Okay, so now let's talk about DBT Cloud. So in order to create a DBT Cloud, you can simply open a new browser and simply say DBT, let's say sign up. So sign up for DBT, you can click here and it will take you to www.getdbt.com. And here you can simply put your email, first name, last name. Company is optional. If you are unemployed, it's fine. If you are a student, fine. If you are in a company, just put the company name, then password and everything, and just click on create my account. Make sense? Make sense? Once it is done, once you have created all these things, then you can simply click on login. Let me just show you. So in my case, let me just say DBT sign up. So I already have the account, so I'll simply click on login. Makes sense? So it will take you to cloud.dbt.com, and let me just put my email account. So this will be the home page that you will also see. Okay, and don't worry about that, because we're gonna just discuss about all the things. All the things means all the things within the DBT. Okay, basically the major ones, because we have already one dedicated masterclass on DBT. And in that particular video, we were using DBT Core, which is the engine behind DBT and which is open source. In this particular project, we are leveraging DBT Cloud, which is a managed service. We do not need to set up anything. There's one more thing, which is called DBT Cloud CLI. Cloud CLI means whatever we are doing here in cloud, we can actually use the CLI, which is cloud, not cloud. Oh man, I forgot the full form. Wait, command line interface. So you can literally use command line interface to interact with your cloud version of DBT. So it is not equivalent to DBT Core CLI. See, there are two things, DBT Core and DBT Core CLI that you use locally, then DBT Cloud, okay, and then DBT Cloud CLI if you want to just work with your cloud version, which is the paid version, but locally. Make sense? Okay, very good. So basically, when you will be just setting up your first DBT account, you will get 30 days of premium services that anyone will get if someone is using premium or paid version. But after 30 days, you will be automatically transferred to the developer option, which is just like free for like every time, like whenever you just want to use DBT, and that's all. And do not need to worry, you do not need to change anything. It will be automatically transferred to the free edition after 30 days. So it's fine. Okay, so do not need to set up any billing, nothing. Everything will be automatic. But yes, for first 30 days, you will get everything premium. But the thing is, whatever we are building here in this project, we are just using free services. You do not need to be in the first 30 days of premium services at all. No, nothing. So that is the best thing about DBT Cloud. It is equivalent to Databricks. Why? Because Databricks also gives you everything for free. CLI, basically DBT Cloud is also giving you everything for free, but just for one developer. That's it. You cannot bring your team within this particular workspace. No. And you can just build one project at a time because you are using free edition. And I think they are just giving you the free edition because you can learn. You cannot build like multiple projects. Make sense? So let's try to build our first project, and I will just name it as, let's say, PySpark DBT and PySpark DBT project. Let's say PySpark DBT project. Make sense? So this is my project name, and even if you do not define anything here, we can still configure it later on. Do not need to worry. And if I click on advanced settings, it will simply say project subdirectory. We do not need to worry about that. Simply click on continue. Okay. So this is my project. Okay. And then it is saying me, hey, do you have any connection? Do you have any connection? No, we do not have any kind of connection, but we will be building a connection. What is a connection? Basically in the DBT, we have two things. One is DBT itself, which is just creating the code and everything. Second thing is the adapter. So in DBT, we can use any adapter, Databricks, Fabric, and all those tools that we have. Okay. So we want to work with Databricks. So we will be using Databricks adapter, and we will be creating a connection with the Databricks. So simply select add a new connection, and let's create a connection with any adapter. See, we have so many adapters. So I'll simply say Databricks, and connection name will be Databricks. Let me add CON, abbreviation for connection. And now it is asking me for two things, host name and HTTP path. You can simply go to your Databricks and go to compute. Let's say here, and within the compute, just click on this particular serverless connection details. And this is your host name. Just provide it here. Where? Here. Oh, here. Host name, and then HTTP path is this one. Make sense? This is your connection. Simple. Option settings, it's fine. So now let's click on save. So this is my adapter. This is my all the things that I want to do. And now it is saying connection usage, environment type all, and all those things. If I click on optional settings, it will be saying catalog. By the way, as per its definition, let me first of all click on edit. As per its definition, it is optional, but do you know what? It is not optional at all. You have to provide the catalog name, have to. So our catalog name is PySpark DBT. Okay. Then let's click on save. And your changes will impact all users. Yes, I'm the only user. Okay. So I hope now it makes sense because we have our connections ready. Okay. You can even land on the same thing if you click on the screen and then Anshlambacollab GSR, then click on maybe create new. If you do not want to create a new account, it's fine. Then you can click on account settings and it will show you the settings page like this. Okay. And these are all the connections that we have. And it is saying Databricks _ connection. Sorted. Very good. So this is just a connection. And if I click on projects, I will see my projects. I just have one project and I cannot create multiple projects. See, this particular button is grayed out now because I do not have access to multiple projects. Simple. Maybe in your case you can because you will be under 30 days of premium services. But once it is over, you will not be able to create a new project. Simple. Okay, makes sense. So this is our project and our connection is also ready. And if I click here, I will see all the configurations here, project subdirectory, artifacts, source freshness and everything, right? Very good. Now we want to start with our development. If you click here in the studio, just click here in the studio and it will say configure environments. Environment required. This project does not have a development environment. So you will simply say configure environment because you would need at least one environment, right? So let's create an environment and click on this connection. Now it is saying development credentials. development credentials. Okay. So now what kind of credentials? See, this is your Databricks. And this particular DBT will access this Databricks. So obviously it should have some kind of permissions. Okay. So if you want to provide the permissions, you can provide the access token. Simply click here and then settings. Then go to identity and access. Not really. Then go to developer. Then access tokens. And let's create a new token. I created this earlier. Let me just revoke it. Let's create a new token. Let's say DBT or basically PySpark DBT. Okay. PySpark DBT. Let me just click on generate, and you also need to just save it. Otherwise it will be gone. And let me just add the lifetime, or basically for 3 days. It's fine. So it's fine. Let me just click on generate. Let me just copy it and let me just paste it here. Okay. Simple. And schema. What is this schema? So basically by default, whenever DBT will be creating our objects, it will use this particular thing called schema. And literally you can just provide anything because you'll be just overriding this thing. But by default, it picks your first name's initial plus your surname. Okay. So it will be called as DBT Lamba. I will just keep it as it is, and target name, just keep it default and just say test connection. Let's make sure like everything is fine. And trust me, it is very, very, very easy to override these things. And usually we just keep it as it is, whatever is there. But then we just try to, you can say, override these things whenever we just deploy our stuff. Make sense? Okay. Very good. Very good. Very good. So now it is just testing our connection, and I think it is completed. So we are good to go. Just click on save. Once it is completed, then only you can just go ahead. And the next step is setting up a repository, basically a repo. So we have so many options: GitHub, GitLab, Git clone, managed. So we will be using managed. What is this managed? Managed is basically the Git services provided by DBT Cloud. So we do not need to set up any GitHub repo, Azure DevOps, nothing. Simply select managed. Okay. And repository name will be, let's say, DBT repo. Okay. Click on create. And it is saying your project is ready. Now it is saying here are some ways you can get started with your project. If you get stuck, assistance, you can chat with support, blah, 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 blah. So what are the options? Start developing in the studio. That is the thing that we will be doing. Okay. Because we want to use Cloud Studio IDE instead of just setting up everything on our own. Second thing is get started with CLI. As I just mentioned, that you can even start or create your project, okay, which will be in the DBT Cloud, but you can develop it locally with DBT Cloud CLI, which is different from DBT Core. Do not get confused. DBT Core is just like the open source engine that you run on your machine, but DBT Cloud CLI is the way to interact with the resources of your DBT Cloud. Make sense? Then check out getting started tutorial, learn about this. And even if you just click it and open it in the new tab, this is something called as setup CLI of your cloud version, not your DBT core. Okay. So I will simply say start developing in the studio. Click here. And what will happen, do you know? It will create a very nice structure of my project, including everything, including every single thing. And just wait. It is saying no optional files and blah, blah, blah. So this is my project, DBT Cloud. If I click here, or basically initialize DBT project as well, it's fine, but just click here and you will be seeing create folder, create file. It's up to you. It is saying get started by opening a file or create a new scratchpad. Okay. Let's say initialize DBT project, because it is a kind of CLI command equivalent to DBT init. Makes sense? So the moment I hit initialize project, all these things are here. All these things are here. Make sense? All these folders. Okay. All these things. See, everything is there. So this is my DBT initialize command, which is called as DBT init. Make sense? And first of all, we need to say create a branch, because we are working in a Git environment. Okay. So we cannot make changes directly to the main branch. Okay. We should always create a feature branch. So let's create a feature branch. Let me just say merge this branch. Not really merge this branch, because we first of all need to commit, which is initial commit to register the branch. or basically initial commit, just say commit changes. Okay, so now all these changes are committed. See, main branch is locked, it is protected because we have established that branch, and now we can create a feature branch on top of this. Let's say change branch, or basically click here as well, change branch. So it is saying which branch do you want to go to. I actually do not have any kind of branch, right? So I can simply click on create branch. I will simply say feature Ansh. Click on submit, and now your branch is created. Okay, and you are now in the feature Ansh branch. Make sense? Very good. Very, very, very good. Now just be with me. I know that maybe you will be having some prior knowledge in DBT. Maybe some of you will be totally new to DBT, and do not need to worry because I will make you feel comfortable. Do not worry at all. So first of all, we need to talk about DBT project.yaml. So this is the backbone of the whole project. Backbone. This is a very big word because this is the truth. Because YAML, first of all, what is YAML? YAML is basically a file format which is more readable, plus which is an alternative of JSON. Because when we want to create so many nested objects, JSON can be very, very complicated, but this is like another version of JSON, which is like more human readable, which is called YAML. Okay. So first of all, let's start from the top. It is saying name, project name. Name means project name, and project name is my new project. Now this project name should be different from your project name that you have defined earlier. What project name did we define? We simply said PySpark DBT underscore project, right? So what do I like to keep it? I like to keep it as PySpark DBT, then project, obviously, and we cannot keep the name same. Then I will simply say internal. Simple. This because it's an internal project. Simple. Very good. What is profile? Profiles are used when you want to develop something locally, but we are not developing something locally, so just keep it default. Fine. This is saying model paths, test path, and all these things. So what are these things? So basically whatever we build in DBT are developed using models. So they are simply specifying the path here, that all the models are here in the models folder and all of those things. Again, all these things are discussed in detail in that particular video that I have just mentioned, DBT Masterclass, 5 hours long video. Simply search on YouTube DBT Ansh Lamba. You will find that video. Watch that video, only then you will be able to understand a lot of things here. Okay, makes sense. I will try my best to make you feel comfortable if you do not have any experience, but you need to take my advice as well. You first need to watch that video. That's why that video is made before this video. There's a common sense behind it, right? Okay, so here we have models and everything. Makes sense. So first of all, I will just save this file, and that's it. And you will see that this file is modified and it is here. Okay, makes sense. So what is the first thing that we need to do? First of all, we want to try to query the data which is sitting in the bronze layer. Why bronze layer? If you remember, we didn't transform our one table which is called trips, which is a fact table, right? We haven't transformed that table yet. So let's try to transform that table and let's see what happens. So basically I can query the data and I can just show you. If I go to analysis, okay, this is an empty folder, and this is basically a scratch pad where we can simply write the SQL queries of our own. Okay, I'll simply say create file, and I will just call it as, let's say, scratch.sql. Let's say create. Perfect. So here I will simply say select asterisk from PySpark DBT dot bronze dot trips. Okay, perfect. Let me just try to run this. And how you can just run this, simply drag this particular thing from the bottom and click on preview, just to first of all preview the data, that how it will look like, and it will simply process it, and let's wait for the results. And obviously this is our preview. See, so we are able to query the data which is sitting in the Databricks, and this is DBT, right? This is the power of connection that we have built using DBT. Makes sense. So that means we can literally query any data. That's true. Very good. But do you know what? I'm gonna just talk about some advanced things here. See, which are really real world. If I click on models, I will see a directory example that I want to delete. Okay. Why? Because I will be creating my own directories here. So models are the things which will be deployed or created for our projects. Anything, tables, views, anything that you want to create will be created using models. Okay. So I know that I will be creating gold layer and silver layer. Okay. Gold layer for sure. Silver layer. Why? Because in the silver layer, I'll be creating only one table, trips. Makes sense. Makes sense. Okay. Okay. Sorted. So I'll be creating my two folders. It's called, first of all, silver. And second of all, gold. Now, what is the advantage of creating the folders within this? See, the advantage is I can directly create the files here under models. But do you know what? If I want to specify the properties differently for silver, I can create the properties file within the silver folder. If I want to create any specific properties for gold, I can create the properties file in the gold folder, which will be only applicable to the files which are in the gold folder. That is the advantage of creating subdirectories here. Make sense? Very good. I will create one more directory. What? Bronze? Obviously no, I already have bronze layer. I'll be creating a directory for sources. What do you mean? I know that I can query the data like this. I know that, but I do not want to do that. Why? Because in DBT, I also want to see the lineage. Can I see the lineage using this? Obviously no, because DBT doesn't know that what is this thing. Yes, we are able to query the data, but it is not internal object to DBT. To make this object internal to DBT, we have something called as sources. Okay, we have something called as sources. So with the sources, I will register this table as my source. Make sense? Okay, and what are sources? Let me just show you. If you go to sources in DBT, let's try to read the documentation. Add sources to your DAG. Okay, let me make it zoom. So basically this is the YAML configuration that we need to write. First of all, let me just copy it. Then I will just show you what does it mean. So if I go here and if I go to sources, if I create a file and I will simply call it as sources.yaml. You can name it anything. Okay, literally anything. I think it would be written here as well. Yes, you can just name it anything. So here I will simply paste that code. So now let's talk about this code. What is this thing? First of all, we have defined the version, which is like self-explanatory. We are simply using version 2. Then this is the sources, basically type of resource that you want to build. We are building here sources. What are different types? Sources, models, snapshots, all those things. Okay. So here we are building sources. So within the sources, this is basically the list of sources. These are basically the list of sources. Okay. So this source name is this one, which is called this shop. And then second source name is Stripe. In our case, I will be creating source name will be, let's say, bronze, or basically source and then bronze. Oh, sorry, silver. Make sense? Source, silver. Source, not silver. I think source bronze. First of all, source bronze and then source silver. Okay. So in the source bronze, what will be the database? Here, database name is equivalent to your catalog. Okay. So catalog will be PySpark DBT. And what will be the schema name? Schema name will be bronze. Okay. And what are the tables I want to register? I just want to register only one table because other tables are already there. I will be simply calling it as trips. Make sense? So let me just copy this and let me just paste it here, because the second source will be silver. Make sense? And the schema will be silver. And here the table name will be so many, because we know that we have trips, like we will be having trips. So for now, we do not have trips here, so we can just remove it. Here we can simply say customers. Okay. Then we have, let's say, another name. and another name will be, let's say, locations, and then we have drivers. Okay, and just make sure the spaces that you're using, because this is really important. This is YAML. Okay, this is YAML. Customers, locations, drivers, and then we have, let's say, let me just check. Payments and vehicles. Okay, payments and vehicles. Then name, vehicles. So these are my sources. Now the advantage is, now these all are the internal objects to DBT that I can just use for the lineage, just to track like how data is flowing. Makes sense? Let me just save it. Okay, and if I click on lineage, so it is saying lineage is currently unavailable, and it will simply refresh it, and once it is refreshed, you will see all the objects here as well, but that's not a big deal. Okay, if I go here now, if I, let's say, I want to use this particular internal object, how I can just use that? It is called reference. Okay, so the code is very simple. Let's say select asterisk from, and then you can simply say double curly braces, then ref function. Okay, so the ref function will say what you want to refer. If you just open the documentation as well, you will see like how you can just refer the sources. So it's very simple. Oh, we do not need to use, ref, we need to use source. So you can simply say source and then source name and then the table within that. So we can simply say here source. Okay, and within the source, I'll be simply name the source. And what is the source name? If we go here, the source name is source bronze, and object name is trips. Make sense? Okay, and I want to use trips. Okay, if I now save this file, and if I just try to, let's say, preview the data, should I see the data? If everything is fine, obviously yes. If anything is wrong, then obviously no. But yes, we are able to see the data. Wow. This is the way we can just refer to the objects which are internal to DBT, which are built in DBT. Make sense? If I open lineage, I will see this particular thing called source bronze trips. And this is an internal object now. If I click on sources.yaml, see all the objects are here. So these are no more just Databricks objects. These are internal to DBT as well, because we have created the sources. And how? Using YAML file. I hope it makes sense. Very good. Now we need to do some things. If I go to dbt project.yaml, first of all, we need to talk about materialization, which is very, very important. What is materialization? So if you see models here, okay, if you see here models, you will see that project name. First of all, we need to change this project name to this one that we have picked, because it should be same, exactly same. Oops, this should be exactly same. Okay, and this is the project name. Within that, we are talking about models. Now what are models? Models are here stored are here. Okay, so within the models, it is saying all the, like, everything which is built inside example folder should be materialized as table. But we do not have example folder, we deleted it. So I will simply say whatever stored in the gold folder, that should be materialized as table. Make sense? That should be materialized as table. And whatever is materialized under silver, that should be materialized as table as well. You can even pick view. Okay, it's fine, but we want to materialize it as a basically table. Make sense? And by the way, we will be creating something called as snapshots for our gold layer. Okay, we will simply using snapshots, but that is fine. I will just let you know like how you can just change it. So let's simply click on save. Make sense? Make sense? Make sense? You can even define properties file in this particular source and gold as well. You can simply create any properties.yaml, and you can even paste this code there as well. And let me just show you properties in DBT, define properties, and this is the property file that you can just use. So this is basically the sources, As we have already talked about, these are the models that you can just simply create this thing. So that's how you can just define the properties file. So models, name, all the configurations, columns, and if you also want to set materialization, it will be there. See, config, materialized view, and then columns and all those things. Make sense? So everything is already discussed in detail, but yeah, we are simply discussing the necessary stuff to complete this project. Make sense? Okay. So this is basically a properties file that we create. You can say, here's an example that defines both sources and models for a project. Okay. Make sense? Make sense? So that's how you can just define the properties. Anything. But we do not need to define any property because we are simply leveraging this dbt project.yaml. Make sense? Okay, very good. So now we want to, first of all, create our silver entity, which is trips. Yes. But for that, do you know what? We want to create an incremental data, basically incremental processing unit. Okay. So how we can just do that? How? So it is very simple. So first of all, let's go to silver. Okay. Let's create a new file and let's call it as trips.sql. Okay. This is our file. Let me close all the other files. Okay. So this is my file that I'll be just using. Okay. Perfect. Perfect. Right. So this is my file. Okay. So here I want to simply load the data. Okay. And how I can just load the data? I can simply say select asterisk from source, right? And then source name is source bronze and then trips. Perfect. Let's try to run that. Drag it from the bottom and click on preview. So it will take some time. It will simply run your code. So this is my data. Makes sense. Do I have anything to transform here? Literally no. Okay. Literally no. But it's fine. Okay. Actually, we can remove payment method and trip status because in the fact table, we should not be having these information. Okay. In the trips. Makes sense because we have trip ID, driver ID, customer ID, vehicle ID, and we just want trip start time, trip end time. Yes, we want date columns, but we do not want start location, end location. Okay. And we also do not want, we want kilometers, and we do not want payment method and trip status because all this information is already in the dimension tables. Makes sense. So now I can simply write the select statement. Okay. I can simply write the select statement here. Let's say select and literally everything that I want. Let's say trip ID and then driver ID and all those columns. Make sense? But I want to show you the power of DBT that you can even use something called as Jinja functions. What is Jinja? Basically, Jinja is a templating language, okay, that helps us to write our code in a dynamic way using SQL. Because see, we learned how we can just use dynamic code using Python, basically PySpark, but how we can just make the same thing in SQL if we are using DBT. We can leverage something called as Jinja. Make sense? So if you want to just work with Jinja, so how we can just work with Jinja? So there are some, you can say, templates, not templates, basically syntax that you should know. Okay. So for example, if you want to work with if condition or basically for loop, you can simply run like something like this. Let's say for I in any list. Okay. And if you just first of all want to create a list, you can say set. I think there's a cheat sheet, very good cheat sheet that you can just see. If I able to find Jinja cheat sheet, just to show you like how you can just create these things. Oh, we have Copilot as well. So very good. So these are the things that we can just define variable name. If we have variable, example, expression, all these things. And I just want to show you like how you can also set the variables if you just want to set the variable. And this is like Jinja template is more used with HTML, but yes, we can leverage it in DBT as well. Let's see if we have something in this particular website. I think we should have Jinja cheat sheet, not cheat sheet, in the DBT reference as well. That will be much better for you to understand. Engine macros. Okay, yeah, this is a very good. That's what I want to show. So let's say first of all you want to create a list. Okay, and it is very simple. So as I just mentioned, like you can simply write set and I can simply say columns. Okay, and then you can simply define the column names. Okay, so now I have two options. I want to create a list that I want to, like for the columns that I want to select. Okay, one thing is I just need to write all the columns. The smarter way is I can simply define those columns which I do not want to read. Let's say I do not want to read payment method. Okay, payment method. And then I also do not want to read trip status. Okay, makes sense. So this is my list. If I want to show you the list, like how does it look like? So I can simply say columns, and let me just show you. If I click on compile, you do not need to click on, I think, preview. Yeah, perfect. So this is my list because this is a compiled code. You do not need to run it. So these are the two items that I have in my code, correct? So what I will do now, I will simply start writing my select statement. I will simply say select. Now, what do I need to write? I simply need to select all the columns, basically all the columns. Okay. And let's do the simple way. Otherwise you will be just confused totally. And let me just give all the, you can say, column names. The one was trip ID, and then it was, I think, vehicle ID. Okay, and let me just see what other columns do we have. Let me just open catalog. Then here in the bronze, tables, and then trips. Perfect. So we have trip ID, driver ID, customer ID. Okay. Trip ID, vehicle ID, customer ID. Okay. 1, 2, 3, 4. 1, 2, 3. Then customer ID, and then driver ID. Then we have trip start time, trip end time. Let me just copy and paste. So why I'm writing like this, you will get to know in just few seconds. Let's say distance kilometer. Fare amount. Trip start is fine. This one, last updated timestamp. Perfect. So let's say we have this list. Make sense? This is the list. Now I want to make my code modular. So I can simply write like this, select. Now, one thing is I will be simply manually writing all the column names, but I can simply run a loop. Okay, what loop? I can simply say for column in columns. Okay, so this will simply run a loop, and once it will run the loop, then I can simply say print the column, not print, basically use this variable. You can treat it like an f string. Okay, because whenever we use f string, we use the curly braces with variable, and that's it. Make sense? And what is the table name? Basically source. I think like this, source, and source is silver, bronze, and trip, right? Perfect. Let me just compile this code. So this will automatically list all the column names. What is it saying? And for, yeah, we didn't end the loop. We also need to end the loop. So I can simply say end 4 like this. Okay, let's say compile. So see, it has literally written me this particular code. That's the power of making the code modular. But there's a small mistake, that not mistake, like I did it purposely. I didn't add the comma, but obviously in the SQL we need to add the comma. So Ansh, just simply do like this, comma, because comma is a text, right? You can do it and if it will work fine, but there's a catch. You cannot literally like comma right like this. Why? Because you cannot write comma after each column, because just look at this code. You can only write the comma till the second last item. But when it will be the last item of the loop, you have to write nothing. So there is a function in Jinja for loop. I think it will be here in the documentation as well. If you will see it here, if it is here, otherwise I can just show you in the official documentation. No. So it goes like something like this. So if it is not the last element of the loop, then it will not do that. Otherwise it will add the comma. So that is the condition that we want to build. So let's say Jinja last, if not last, something like this, for loop. And I hope if our search engine is good, it will return me the right web page. Yes, it is called, by the way, thanks to Copilot, because this is the right code. So it is saying if not loop.last, then add the comma, otherwise do not add the comma. Simple. So I will simply say if condition in my code, and I will first of all remove this comma and I will add this if condition after this. So I will simply say, I know this is complex, not complex, this is new, and you need to watch that particular DBT Masterclass video in order to understand all these things, because we are simply applying that knowledge that we have learned there, right? So I'll simply say if, okay, and we will use percentage. Perfect. If loop.last, basically not loop.last, right? So if not loop.last, then add comma, otherwise simply if this is not the last element, then add comma, otherwise end if. Do not do anything. Simple. Now let's compile the code. Now let's see what is the output. Perfect. Trip ID comma, vehicle ID comma, customer ID column comma, but after the last column we do not have any comma, because we have specified, hey, add the comma after column variable if it is the last element of the loop. If not loop.last, then add comma. Simple. We can even save it. So this is my select statement that I have simply defined here. Make sense? Make sense. Okay, very good. So now if I simply run my model, do you know what it will do? It will simply create the table on top of this select statement. That's how DBT works. Okay, but I want to make it incremental. Okay, so in order to work with incremental materialization, yes, we have a dedicated materialization for it. It's called incremental. You need to tell it that, hey, we want to create an incremental object. And now let's talk about that as well. So if I go to, and if I write DBT incremental materialization, you will see that we can literally define the where clause, like on which column we want to incrementally load the data. And yes, this is the configuration that we can define. Config materialized equals to incremental. Make sense? Okay. So Ansh, Lamba, yes sir, you said that we defined materialization in the dbt projects.yaml, right? Okay, makes sense here. But now as per the code, it is defining materialization in the code itself. So what is that? Basically you can define materialization anywhere, and there are levels. So the first level is the parent YAML, which is for everything. But if you define materialization here like this, let me just show you. If you define materialization like this, let's say you want to materialize it. Basically, this is a configuration. You can write your configuration here or you can write your configuration here. Simple, not a big deal. But when you define your configuration closer to your object, that will take the priority, that will take the precedence. So if I'm defining here materialization equals to incremental, and if I have written materialization as a table, it will not work. Table will be like overridden by this. So we are simply overriding this value, defining it here. That's why I told you, even if I'm like defining it here as a table, that's fine, because I can override it using my config closer to the model. So this is my model trips.sql, which is closer to this particular config, because we are defining config within the same file. This is the closest config. Make sense? So this is defined, but this is just the 50% of it. You cannot work like this. Hey, I have defined incremental. Now my model will be incrementally loading the data. Bro, this is only one part of it, because we just work with this particular materialization using a macro. Macro is basically a function. So now this macro will come into the picture. I will simply say is incremental. Okay, is incremental. So if this model is incremental, which is okay, if this is incremental, then run this code, which is this one, where and how we just incrementally load the data. I will simply say where, which is the CDC column. CDC column is last updated date, basically timestamp, should be greater than what? Should be greater than or basically equals to, not equals to, greater than, select maximum of last updated timestamp from what? From this model, silver model. So there is another function called this. And now let's read the documentation. You will understand it better. So what is it saying? It is saying that if it is incremental, we can just add if, because that's just a if condition. We will simply filter our data, okay, and on what? On the basis of maximum date. And what will be the maximum date? Which is this one. Okay, makes sense. And maximum date means, see, just try to understand. Let's say this is your source, this is your destination. Okay, you want to incrementally load the data. So initially, when no data is there, what will happen? What will be the maximum of this date? Obviously null. So we can simply define any date which is so small. Okay, so what will happen? All the data will go there. Make sense? Now, once the data is there, let's say there is some data here, then what it will return? Max of something, obviously some value, and then it will only load that data only which is greater than that date. This is the fundamental of data engineering, or basically you can say incremental load. That's why we say fundamentals are the backbone of these modern technologies, because in the modern technologies you will directly work with the fundamentals. Make sense? Okay, so let's try to improve our code. We can simply first of all say if, because that's just an if condition. If is incremental, okay, then we will simply say max of this, and now I can write coalesce. Okay, coalesce. If it is null, then simply return a very small date so that we can simply read all the data. Make sense? Okay, very good. This is the code. And now this is your this function. That means from this particular current model. Okay, now let's say end if. Perfect. This is my model. Let's save it. Let's try to preview this. Let's see what happens. We should see all the data, because obviously we do not have anything in the target data, and the date will be picked as 19000101. Make sense? Very good. So that's your incremental data. Now we will be applying upsert as well. Wait, Wait. So it is simply processing the data. Okay, so perfect. We are able to read the data perfectly. Very good. So now this is just the incremental data load, not upsert. In order to apply upsert, we need to define only one small thing, and we need to say key column here, key column. And let me just show you if it is available here. Defining unique key, yes, this is the optional part, but we want to make it not optional, mandatory thing, because upsert is the backbone of these silver layers. Okay, so in the unique key, you can simply say, what is a unique key? Unique key is my basically trip ID. Make sense? Unique key is your trip ID. See, whatever column is your unique. This makes your model can handle upsert. Make sense? So it is called as merge command basically for your model. Okay, makes sense. So that's how you work with these things. So now what will happen? Do you know what will happen? Let me first of all save it and let's say preview. Do you know what will happen? You will say Ansh Lamba. This is just a select statement. Whatever we are doing, and we agree that we are using Jinja for making our code modular so that we can just reuse it. Everything is fine. But where is our create table command? So whenever we work with DBT, we do not need to worry about create table command, because we just define the select statement, and whatever the output of that select statement will be going to our create table command. Everything, literally everything. Okay, that's cool. Yes, everything will be going to the create table command automatically behind the scenes, and I will even show you the command, the real command that will be running behind the models. How? Let's try to first of all run this thing, and simply click on this particular button, which is the CLI. Okay, cloud CLI, which is in the cloud, not local CLI. So I'll simply say DBT run. What is DBT run? DBT run will run your all the models, and in our case we just have one model, so simply say DBT run, and that's it. And now let's wait, and you will see that it will be running our model that we have created. So we have created only one model so far, trips, so that is why you are seeing trips here, and it will simply run all the things, and it is done. Yes. And let's check if it has created our trips data in the silver layer, right? Let's see. And let me just refresh it. And ideally it should not. What? Yes. Because remember, we defined the schema as DBT Lamba. So my table, my model will be here. See, trips. Whoa. Okay, makes sense. Okay, but that good thing is trips table is there. Okay, I will even show you how you can just customize your schema name as well. That's not a big deal. But first of all, let's see how this table is created. So if you just click on the, I would say details, and if you scroll up, you will see all these things here. So see, it has already created create or replace command automatically, and it is a delta table. So delta, and this is our command. That's how it runs your original code in the background. I can even show you here as well. So whatever we run in our DBT will be saved, I think here, let me just show you in the target. See, this is grayed out because this is not actually which is deployed, but this is for us so that we can just see. If you open git ignore, this will be mentioned here. See, because we do not want to deploy any target, right? So click here in the target and just click on compile. And the compiled, this is my project internal, and this is models and silver trips.sql. So this is my compiled code that it has compiled for me. Every information is stored here. And if I say, let's say compiled and then target, then I have compile and run and everything manifest. Yeah, everything is there. You can just actually explore because it is totally grayed out. So yeah, that's how it can run your all the things, and you know how it created your create table statement as well. Make sense? Okay, very good. Now let's talk about, hey Anshlamba, what if we want to just create our objects in dedicated schema? How we can just do that? So there's a command to override your schema behavior. So for that, you can just go to DBT project. Oh man, this UI. Okay, so this is your project, DBT project. Here you can define your schema. Here. Make sense? And let's try to look at the documentation. So let's say custom schema DBT. So custom schemas DBT, and these are all the things that we have. Okay, and if you see models, okay, we know that, okay, this is a model, and we can even override the schema in the main config file, which is the code itself, but we do not want to do that. We want to configure this schema in our dbt project.yaml. See, apply it to a subdirectory of models by specifying in your dbt project.yaml. We can do it in the dbt project.yaml as well. Make sense? So now let me just see if a good example is there. Otherwise, I have to use my own. Okay, custom schemas, custom databases. Okay, yeah. So it is not like direct to that, but I can just use this one and I can modify it using my own example. So this is, let's say, models. Okay, then I can simply say within my models, I can say plus database. So for example, if I go to my models, okay, and within my silver model, I can simply say something like this, plus schema, and schema name will be, let's say, silver. Make sense? Schema name will be silver. So now if I deploy it, let's say I run the command for more time. So this will deploy the object in the silver schema. Now, as per the rule, let's see what will happen. So basically this will not deploy in our silver schema. Why? Let me just show you. So if I open my this thing, it will create a new schema. What is the new schema name? It will be called as DBT Lamba silver. So that means earlier it created the DBT Lamba, which is a default schema. This time it created another one, DBT Lamba silver. So now every time it creates a schema, it always uses DBT Lamba as a prefix. But now our 50% of the work is done because we have added silver. Now the 50% of the task is to remove DBT Lamba as a prefix. Okay, and in order to do that, I think they should just tell you how you can just do that. Basically, see, this is the macro that we can just run or basically create. Okay, that we can simply create. So this is basically the macro, basically the function that DBT uses to create or generate the database or basically schema name. If I go to custom schemas, I will see the schema macro. See, this is the one. So this is the code that DBT uses by default. It is called generate schema. Okay, they uses it, but I can override this. I can simply create one macro. I don't need to create a macro. I will simply copy paste it. I will simply create a new file. Let's say I will say generate custom schema .yaml. Okay, create .yaml or create SQL. I think it will be, I think it should be SQL or YAML. I think so. Yeah, it should be SQL. Yeah. So it is also saying that to generate this macro, copy this example in section, okay, into a file named generate schema name.yaml and make changes as necessary. Because by default, be careful, DBT will ignore any custom macros installed, included in the installed packages. So we have to just create the file with generate schema name only, because it will read that file. So let's rename this file. It's called, let's say, generate schema name Okay, dot SQL. Okay, makes sense. Okay, so this is created outside this. So let me just delete it from here. Let's create it inside this macros. Create file, generate schema name dot SQL. Okay, perfect. So this file is created. As you can see, it is written that you have to create a generate schema name dot SQL inside the macros. Okay. So now if I paste that code here, okay, and we know that this is the part which is using default schema. So I can simply remove this part and I can simply say save. Now, if I say DBT run, now let's see what happens. Now let's see. This is interesting. Now let's see. So perfect. Now let's check our Databricks, refresh it. Okay. Now let's check the silver layer. Silver. Perfect. It has trips table now. Perfect. So now it has created this particular table inside the dedicated schema. And it is amazing. Now we know like how we can just create the table using DBT and now it will be automatically created. Makes sense. Perfect. So all the things are now clear how we can just populate the incremental upsorted data for our DBT. Okay. Perfect. So now our silver layer is also ready. Now we're gonna talk about how we can just build the slowly changing dimensions using DBT. This is challenging. Okay, so now let's see how we can just work with slowly changing dimensions using DBT, and it's called snapshots. It's called what? It's called snapshots in the DBT language. Slowly changing dimensions are called as snapshots. Makes sense? Sorted. And they are really handy and they are very useful. And I will literally show you how you can just create basically the snapshots. Okay, so now let's see how you can just build the snapshots one by one. Makes sense? Now let's see. So now let's talk about slowly changing dimensions. Mike, come here. So now let's talk about slowly changing dimension type 2. If you are not aware about slowly changing dimensions, you should be. It's 2025. It's almost over. 2026 is coming and you are still unaware of slowly changing dimensions. What are you doing, bro? Sister, what are you doing? So if you do not know about slowly changing dimension, basically, see, our trips is the fact table in which we store all the transactions. Dimension is just like the, you can say, contextual data to those fact tables whenever you want to provide some context. Okay, again, fundamentals. Fundamentals are important. People are jumping directly on the tools and technologies, forgetting about fundamentals thinking, and you are just jumping on the new technologies. So it's fine. No worries. Here's Ansh Lamba. By the way, if you just want to brush up your fundamental knowledge, I have a video for you for free. Just go on YouTube and just search data engineering fundamentals. You will get everything. And obviously this is regarding data warehousing. I have a video for you. Just go on YouTube and just search data warehousing masterclass Ansh Lamba. You will get everything for free. Everything for free. Just show your love on this channel. What are you doing, bro? So basically we're gonna build slowly changing dimension type 2, which is the next level of slowly changing dimension, because slowly changing dimension type 1 is nothing but just applying the upserts, which are good, but in the modern days we do not much rely on slowly changing dimension type 1 because slowly changing dimension type 1 do not retain the history, but slowly changing dimension type 2 retain the history. Amazing thing. Let me just show you with an example. Don't worry, I am here to just explain you everything. So let's say DBT snapshots. Don't worry, I'm not directly jumping on the snapshots, but they have a very good example on their webpage. That's why I want to show you that. Okay. Feel my emotions. Feel my emotions. So this is the, yes, this is very good example. So basically you would have ordered so much of stuff from online. I know you are very rich and I know you love shopping. I know everything. So basically let's say there is an order ID equals to 1. And when you ordered the stuff, okay, anything, shoes, clothes, whatever. So at that time status would be pending, because at that time you would have just placed the order. But let's say after some hours or basically next day or basically after few days, same order ID with status will be changed and it will become shipped instead of pending. So if you want to retain all of this history, like when the order was placed, when it was shipped, when it was delivered, when it was returned, if you would have returned it, okay. So all these things can be stored in the form of slowly changing dimension type 2. That's where the concept of snapshots come into the picture. Okay, so let's look at this example. So see, earlier it was pending and it was, what are these two columns? These are two columns that will be created automatically, from and to date, DBT valid from, DBT valid to. Basically, when this ID was created, okay, when there was no this record, okay, so what was the value of this? Obviously from means when this record was added. Valid to, that means to which date this record is valid. Obviously till the date when the data for that particular record is not changed. That means the moment this record is changed to, let's say, shipped, or basically any ID or any column is changed, then this validation is expired and new validation is started from the 2nd of January 2024 and valid 2 is null. Why null? Now you have two options. What is the expiry date of, let's say, this mouse? Why? I love my mouse, bro. If this would be expired, no worries. Let's say this, what is the expiry date of this mouse? Okay, if I say null, that means it will never be expired. If I say the expiry date of this mouse will be sun, basically year, 999999 and 909, very big date from now. By the way, 9999 makes sense. What is 99? We just have 12 months. Okay, 9999, 1, 2 and 0, 1. Let's say this one. So in both the scenarios, I want to say that the expiry date of this particular mouse will be very, very big. Okay, so some organizations like to have null in their valid to column. Some organizations like to have a very big date. I personally like to keep a very big date because I do not want to keep nulls in my column. I don't like nulls. Simple. Okay, so that's all about the snapshots, or basically slowly changing dimension type 2 from the conceptual perspective. Now how we can just implement it, I will just let you know. So the thing is, snapshots are recently updated in DBT. Earlier we used to write SQL statements, but now we need to write YAML statements if we want to create snapshots. And you know what? YAML are better and you will feel why. It's very easy to configure. Okay, so let's actually try one example. Let's take any example if we have any good example here. Otherwise I have to put my own example. So I think this is a good one. Okay, and this is see also using this particular function. Makes sense. This is good. Let's copy this one. Okay, so in order to create snapshots, basically slowly changing dimensions type 2, we cannot store our models in the gold layer or any kind of layer. No, there's a dedicated folder for that. It's called snapshot. See, create a YAML file in your snapshots directory and you can name it anything. Let's say customers and blah blah blah, trips, whatever. Trips is not a dimension, but yeah, you can say locations and all those things. Okay, and add your configuration details. You can also configure your snapshot from your dbt project.yaml file docs as well. Yes, you can, but I like to create snapshot within the snapshots folder. Why? Just tell me one thing. Come here. These are my models. This is silver, gold and everything. In the Databricks, not Databricks, DBT, it's not Databricks CLI. So DBT project.yaml. In this particular file, we should define like how we want to build our projects in the Databricks. But within the dedicated folders, we should tell what to build, how to build, right? Very good. So let's go to the snapshots folder. It is already there. I love this folder structure created by DBT. We do not need to do anything. Let's say create file and it will be called as, let's say, customers.yaml. Let's not customers.yaml basically, because in this particular YAML file, we will be creating all the snapshots. You can create individual YAML file as well. Yes, you can create multiple YAML files within your folder, but it's better to just go with the same YAML file. So I'll simply say snapshots, or basically you can say SCD types or basically SCDs. Okay, create. So as you can see that we can create any file, multiple files as well, it's fine. But I want to create only one file with multiple snapshots. Okay, let's paste the code here. And this is our code that we have pasted. And we need to rename it called .yaml. Otherwise it will not pick it up. Yeah, perfect. So this is our snapshots. Make sense? And this is a name. Name means this is our first snapshot. And we want to create snapshot as you can say customers, or basically dim customers. It will make more sense. Dim customers. Okay, so what is the relation? What is relation? Relation means source. What is the source of this table? Obviously, we have source and it's called as source silver. Makes sense. And what is the name? It's called, I think, customers. Makes sense. Now schema. What will be the schema name? We want to keep the schema name as gold. Okay. Database is PySpark DBT. Unique ID. This is very important. What will be the key column for our dimension customers? It will be customer ID. If you have multiple columns, you can simply add comma and just add those things, or you can just add a list as well. Strategy is very important. Timestamp. Basically, there are two strategies. Always go with timestamp if you can. If not, obviously you have to pick the other strategy. Other strategies, like I'm not a big fan of that. Timestamp strategy means, let's say you have data in your target table. Let's say this one. Let me just tell you with an example, because with an example you will understand better. So let's say this is your source data. This is your target data. Okay. You moved some piece of data from here to here. Let's say order ID 1. Okay. Let's say order ID 1. And this is also here. Okay. Makes sense. Now, next day you got the data as 1. Okay. As 1. And now this one was shipped. This one was delivered. Okay. So now this one with shipped is already in the target table. Makes sense. Makes sense. Okay. Very good. Now, how this would know, basically this DBT engine, basically any engine would know that delivered will come after shipped. You will say it's common sense, right? Bro, DBT will not go on Myntra and just do the shopping, right? It doesn't know like delivered will come after shipped. So how does it know? It will know based on a timestamp column that, hey, shipped was happened on this date. Delivered was happened on this date. So we need to keep delivered after shipped. So we need a column which will decide the value, like which value is updated after which value. So that is why we have a column here, last update time, right? Last update timestamp, I guess. Last update timestamp. Perfect. And DBT valid to current. We have two options. We can either keep it null, or we can also keep it like this. 9999 12 or 31st, and you can just celebrate your new year. Perfect. And instead of null, I personally prefer keeping this value instead of null values. So this is my first snapshot that I can just create. Yes, with just this configuration, you can literally create slowly changing dimension type 2. And if you have created slowly changing dimension type 2 using PySpark code, you would know like how long it take, how much of efforts it take. Okay. You need to apply upsert command 2 times, because one time you will update and flag those records as expired. Then you will update the records. Then you will apply the filters. All the things are gone using this particular strategy called snapshots. Makes sense? Very good. So let's see if we have to do anything else. Almost all the things are fine. Since snapshot focus on configuration, the transformation logic is minimal. Typically you would select data from the source. If you need to apply transformation like filters, deduplication, very good. This is very good point. Glad I just looked at this documentation. So basically sometimes you would need to apply deduplication step as well. We have already applied deduplication step in our silver layer, but sometimes people will not be applying deduplication step in the silver layer. In that particular scenario, they can add a kind of transient layer which will act as a source for their, you can say, snapshots. Okay, which will act as a source for their snapshots. Okay, makes sense. Now what is this ephemeral? Because we have seen incremental, table, view. What is this ephemeral? Ephemeral is basically a kind of, you can say, query or basically temporary view that it creates for us. Ephemeral, which will not be materialized. No, it will not be created in your Databricks. No, it will reside in DBT. That's it. That means it is a kind of temporary view. It will only run this query as a source, but it will not materialize it. That's the power of ephemeral. We do not need to use it because we are already applying deduplication step in our silver layer. But if you do not have, you can create a step for deduplication and that's it. And you can just treat it as your source. Simple, 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 simple. So that's how you can just do that. Okay, makes sense. So now let's try to run this particular thing and let's try to build. And you cannot use it, like you cannot create this snapshot using DBT run. You have to hit snapshot, DBT snapshot. Let's hit enter. Let's see if it creates the snapshot for us. Let's see. And we will be able to create this particular object in the gold layer, gold schema, without any kind of default name, because it will run our macros folder first of all, and in that it will run our SQL file to remove that particular prefix from the schema name. Simple. Okay, so it is running dim customers for now and it failed. Very good. Why? To any resources there are one unused configuration. Okay, what is the error? Okay, start snapshot, select asterisk. Okay, unresolved column is a suggestion. Unresolved column. Oh, okay. Oh, it's called last updated timestamp. I think I just misspelled something. Last updated, not update. Ansh Lamba. Okay, it happens. It happens. DBT snapshot. Let's run it for one more time. Okay. Let's see if it runs fine. Yeah, perfect. Are you excited to see the result? Are you excited? Let me just check the list that I have created before creating this project so that I do not miss anything, because we are almost close to complete this project. Okay. Okay, makes sense. Let's check our dimension. If we go to our Databricks, if we go to gold layer, oh, we do not have a gold schema, right? Yeah, but DBT will create for us. Oh wow, man, thanks DBT. So we have dim customers, very good. And if we see the data, it's absolutely perfect. Very good. So now what I will do, I will simply create more dimensions like this, and I simply need to copy and paste this code multiple times. So this will be my dim locations. Okay, and source will be locations. Locations and location ID. Okay, everything else is fine, makes sense. Then I want to create dim drivers. Okay, drivers and then driver ID, and then perfect. This is also fine. Then I have, I think, what do we have? Payments, vehicles. Okay, payment ID, dim payments. Perfect. Okay, 1 2 3 4, one more, dim vehicles. Perfect. Vehicle ID. Perfect. Let's try to create all these snapshots. So I'll simply run DBT snapshot and it will run all the dimensions together, and it will run our dim customers for one more time. Why? Because that is also a dimension. Why it is running 4? 1, 2, 3, 4. Oh man, I think I forgot to rename it. Cancel. Oh, bro, why did you cancel? 5th one was also added. Okay, it's fine. Let's run DBT snapshot. So it will run our DBT basically snapshot for dim customers as well. And this time it will not simply add more records, because it is like incremental processing and it knows how to process it internally, because this is slowly changing dimension type 2. So this is fine. Okay, so now it is running dim vehicles as well. All the dimensions are there and I'm so happy. And let's refresh it and let's see all the dimensions ready. Perfect. If we see dim customers, it's fine. It's there. See, everything is there, bro. Everything is there. So we have all the things: dim customer, dim drivers, dim location, dim payment, dim vehicles in the gold schema. Why? Because we manually changed the setting to edit the prefix for schema name. Simple. And I know that you also got some hint about, you can say, ephemeral data type. Okay, that how you can just use ephemeral and blah blah blah. Makes sense. So now our all the dimensions are ready. Makes sense. All the dimensions are ready. So how we can just work with, you can say, fact table. That's interesting. How we can just work with fact table, because all the tables are ready, right? And in our gold layer, if I open models, our gold is empty because we'll be creating our fact table within this. Make sense? So in order to create this thing, okay, we need to apply basically joins based on the ID. Yes, obviously. And let me just check. Yes. So, and we have a source called silver.trips. Make sense? Because obviously we do not need to create a dimension for trips. Trips is a fact table, but that fact table should only be, you can say, having only the IDs, and it has all the IDs, right? I think so. It has all the IDs. If I close this one, and if I go to, let's say, gold, okay, I think we have IDs. Okay, makes sense. I think, yes, I think we can create a snapshot for our fact table as well. Why? Because we just need to apply, like, this is optional step. Ideally we should not, but I just want to move my, you can say, trips into the gold layer as well. I just want to do that just to make everything available in the gold layer. Why? Because we, as a data engineers, we do not just give access to the silver layer. We sometimes give, but we do not every time give the access to the silver layer to our data analyst or any kind of business analyst or any kind of report builder or anyone. We just simply provide the access to the gold layer only. So I just want to move my stuff to the gold layer. That's why I'm just moving my stuff to the gold layer. That's fine. Usually we create views, aggregated views in the gold layer, but that's fine. Let's create our snapshot for fact table as well. And let me just show you. Let's create a new YAML file. Okay. Let's create a new YAML file. Let's create a new file. I will simply say fact table. Okay. Fact.yaml. Makes sense. And let me just say fact trips. Okay. And what will be the source of this? Obviously, this is not a source. This is something else. What is that? So basically, when we just define this one, we simply use source. Make sense? We simply use source. But here we cannot use source. No. Why? Because source is the object that we created for our, you can say, DBT, right? Like source, which is already in the, you can say, Databricks, but we wanted to just bring it to our, you can say, DBT. But for the trips, we didn't bring the silver object. We just brought the bronze object. But if we want to just use it as a source, then we have to use it as a, you can say, real object of DBT instead of source. Really? Yes, really. So how you can just do that? Basically, you simply need to remove it with the ref function. Ref function, what is that ref function? Ref function is the abbreviation for reference, where you simply refer the object that you have within the DBT. Let me just tell you. So basically, this is silver layer, right? Trips.sql. So what will be the model name? It is the same name that you keep for the file name. Trips.sql, it will be trips. So I can simply say the relation is ref and the reference is trips. Oh, so that means I'm trying to query this particular trips. That's it. And I can even show you if you want to. So let's say if I go to my analysis, scratchpad, if I simply try to query this table, I can simply say ref and then trips. I will see this particular data. Let's click on preview. So that's how we just refer to the previous models. Make sense? Makes sense. So see, I can see this thing and this is the lineage. So this is my trips, which is a silver object, and this is my source. This is the lineage. Make sense? Good. So I will simply use it here ref and then schema is gold. This is, I think, trip ID and timestamp last update date is fine. Everything is fine. So let me say save and let me just run DBT snapshot for one more time. And boom. And boom. It will simply create all the 5 dimensions and one fact table automatically. Slowly changing dimension type 2. Can you imagine? Do you know how many fact trips is there? Okay. Perfect. All the objects are very neat and clean. Very, 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 very beautiful. Okay. So now if I just refresh it now. So in the gold, I also got fact trips. Very good. I have literally everything now. Everything that I want. Everything. Literally everything. Did you like DBT? Just be honest. Did you like DBT? I love DBT. I love DBT because it makes your code modular, and I love modular code. I hope you learned a lot, and now let's try to commit everything and let's call it as development completed, bro. Commit changes, and we are simply committing all the changes. Then we will simply merge this thing into our main branch. See, merge this branch to main. Let's merge it so that our all the development will be merged back to the main. See, now this is a main branch and all the objects are here. Very good. Now there's a small homework for you. What is homework? So obviously we have completed our, you can say, project. We have completed our dimensional data model. We have learned so many new things, and professionally, classes, modularity, slowly changing dimensions type 2, incremental ingestion, Spark streaming, dynamic code, everything. First of all, one request, just drop a lovely comment on this comment section. Okay. Second thing that I want to show you, that there's a small homework for you. You need to create at least 3 business views in the gold layer using multiple KPIs. Let's say you want to calculate all the number of trips in some region, or maybe based on some, I don't know, like just do some analysis. Okay, just build 3 views. It's called business views in this gold layer. Okay, and you already know how to do that. You know how to use Jinja, you know how to use loops, you know how to use if conditions, you know everything. Just do it for me. Okay, very well done. And now the last part, not the least part, because once you develop everything, if you do not share your data warehouse with your developers, your downstream, what is the role of developing these things? So let's say everything is built, and if I go to catalog, my catalog is looking very beautiful, very perfect. Okay, so now let's say this is my catalog. Okay, and now this catalog needs to be shared with the data analyst, or basically BI analyst, or basically anyone who wants to build the reports. So how you can just do that, you already know. By the way, you can simply go to compute Okay, and then you can go to, let's say, this particular SQL starter warehouse, connection details. Here are the connection details that you can share. If they want JDBC, you can just give it. If they want server name, HTTP, you can also give it to them. It's up to them what they want to do. Makes sense, makes sense, makes sense. So this is your project, end-to-end project, and don't worry, I will just upload all the notebooks. You would have already downloaded it, okay, by now. So that was all about your end-to-end data engineering project using open source frameworks such as Apache Spark and basically PySpark and your DBT. How was it? Do let me know if you loved this video. Do let me know if you want me to continue creating all these particular videos, projects, and just show your love and support in the comment section. Share this video with others and just click on the video coming on the screen right now because I will see you there. Bye bye.